SAP EWM Scenarios Masterclass Part 2. SAP EWM Advanced Integrations, S/4HANA and Troubleshooting Scenarios. Welcome to Part 2 of the Ultimate SAP EWM Consultant Interview Scenario Series. While Part 1 focused on the fundamental, day-to-day physical operations within the warehouse walls, Part 2 is designed for senior-level mastery. We are entering the engine room of enterprise logistics. Here, we will dissect how EWM integrates with cross-functional ERP systems, transportation management, production, quality management, and automated material flow systems. Additionally, we will cover complex debugging, performance tuning, and the latest S/4HANA embedded innovations. If you want to differentiate yourself as an architect rather than just a functional consultant, these are the scenarios you must master.
Part 1 Recap. Part 1 SAP EWM Core Operations and Internal Processes Recap.
In Part 1, we covered 135 core operations scenarios spanning inbound, outbound, put-away search sequences, WOCR, queue management, RF frameworks, HU management, batch control, physical inventory, replenishment, and wave management. If you missed Part 1, make sure to check the link in the description to complete your foundational mastery.
Following 17 categories are covered in this Part 2 video.
This advanced segment consists of 122 scenarios distributed across 17 enterprise-level categories. Category 12, PPF and printing scenarios, 8 scenarios. Category 13, ERP integration scenarios, 10 scenarios. Category 14, TM transportation management integration scenarios, 7 scenarios. Category 15, Yard Management Scenarios, 7 scenarios. Category 16, MFS and Automation Scenarios, 8 scenarios. Category 17, Exception Handling Scenarios, 10 scenarios. Category 18, Performance and Support Scenarios, 8 scenarios. Category 19, Migration and S/4HANA Scenarios, 7 scenarios. Category 20, Client Requirement Scenarios, 9 scenarios. Category 21, Debugging and Troubleshooting Scenarios, 10 scenarios. Category 22, Production Integration Scenarios, EWM-PP and MES, 8 scenarios. Category 23, Quality Management Scenarios, EWM-QM, 7 scenarios. Category 24, Value-Added Services VAS and Kitting Scenarios, 6 scenarios. Category 25, Cross-Docking Scenarios, 4 scenarios. Category 26, Returns Management Scenarios, ARM, 4 scenarios. Category 27, Labor Management Scenarios, LM, 4 scenarios. Category 28, Modern S/4HANA Embedded and Cloud Scenarios, ASR and Fiori, 5 scenarios. Total 122 scenarios in Part 2. Let's begin with Category 12.
Category 12, PPF and Printing Scenarios.
The Post-Processing Framework, PPF, is the primary engine used by EWM to schedule and execute actions, primarily document printing and automated background triggers. Troubleshooting PPF is one of the most common requirements for an EWM consultant. These scenarios test your ability to diagnose printer routing, prevent double printing, handle delay logic, and manage output determination failures.
Category 12, PPF and Printing Scenarios.
Here are the 8 scenarios covered in this category. Scenario 136, Picking List not printing automatically. Scenario 137, HU labels not generated after packing. Scenario 138, PPF action triggered multiple times. Scenario 139, output determination failure. Scenario 140, printer determination based on work center. Scenario 141, smart form not triggered after GI. Scenario 142, delayed printing requirement. Scenario 143, email notification after outbound completion. Total 8 scenarios. Let's begin with Scenario 136.
Scenario 136. A pick wave is released and the tasks are generated, but no paper pick sheets are sent to the floor, halting manual pickers. How do you troubleshoot and resolve this automatic printing failure?
Answer: this indicates a breakdown in the PPF action trigger or the spool parameter setup. I would resolve the issue using the following steps. 1. Analyze PPF processing log. Go to Transaction SBPFP, input the warehouse order or delivery document number, and check the status of the print action. If it is red, Check the detailed error log for a printer configuration mismatch. 2. Verify action profile assignment. Ensure that the correct action profile is assigned to the warehouse order creation rule WOCR or the warehouse process type WPT being executed. 3. Inspect condition records. Open transaction/SCWM/WDTP to verify that a valid condition record exists for your warehouse, document type, and printer name. 4. Check spool parameters. Confirm that the output device printer is defined in SAP SP-AD and that the user master or the work center is assigned a default output device. Pro tip: if the PPF light is yellow in SBPFP, it means the action is scheduled but not processed. Check if the execution time of the PPF action is set to processing on save value 4, but the parent document hasn't been saved, or if the background spool processing job is stuck.
Scenario 137. An operator at a pack station closes and confirms a shipping pallet HU, but the physical label printer remains silent, blocking the staging team from wrapping and shipping. How do you resolve this HU label printing failure?
Answer: HU-related printing relies on the interaction of the work center print profile and packaging material settings. I would troubleshoot the issue as follows. 1. Verify work center print profile. Check the configuration of the packing work center in table/SCWM/TWORKST to ensure a valid print profile is assigned to the station. 2. Inspect HU print action. Confirm that the PPF action/SCWM/print_HU is correctly assigned to the active packaging material type. 3. Check packaging material master. Ensure the packaging material master data has the packaging material type and handling unit type maintained. EWM uses these to determine the correct layout format. 4. Verify printer assignment. Check /SCWM/PRT_DET to ensure the work center and user ID are mapped to the correct physical IP address of the target printer. Pro tip: in HU printing, if you have multi-level nesting boxes inside a pallet, ensure that the print level in the print profile is configured to target either the root HU or the single H used depending on whether you need a master pallet label or individual carton labels.
Scenario 138. A warehouse order is updated, but instead of a single picking list, the printer generates 5 identical copies, wasting paper and confusing the picking crew. How do you resolve this duplicate PPF trigger?
Answer: duplicate printing is usually caused by incorrect multiple processing settings or overlapping condition records. I would resolve the duplication by 1. Review PPF action definition. Go to Transaction SBPFP and check the action definition settings. Ensure that the multiple processing flag is disabled or restricted to only once. 2. Inspect condition records. Open /SCWM/WDTP and check if there are multiple overlapping condition records, for example, one general record for the storage type and one specific record for the product, both triggering the same print action. 3. Verify business add in baddie logic. If a custom baddie is used to evaluate print criteria, ensure the baddie does not contain a loop that calls the create_action method multiple times on the same object instance. 4. Check user defaults. Ensure the user's SAP parameters SU3 do not have duplicate print parameters or active options that override EWM's output control. Pro tip: in the PPF action definition, set the execution time to immediate processing value 3 and uncheck the changeable option. This prevents subsequent system updates of the same warehouse document from re-evaluating the conditions and triggering a second print file.
Scenario 139. The shipping office attempts to print a bill of lading BOL, but the system returns a determination failure status, stopping the carrier from leaving the dock. How do you resolve this output determination failure?
Answer: this indicates that the PPF engine cannot find a matching condition record to execute the print action. I would troubleshoot the failure using this sequence. 1. Review field catalog and access sequences. Check the access sequence assigned to the print action to ensure the key fields like carrier, ship to, or route are active in the EWM field catalog. 2. Validate condition records. Go to /SCWM/WDTP or the specific output determination table and check if a record exists for the exact combination of variables present on the outbound shipment. 3. Check partner profile mapping. Ensure the customer or carrier business partner roles are maintained, as EWM frequently uses the recipient attribute in its access sequence. 4. Verify action merging. Check the merge tool in the action profile. If it is set to max, one action for each action type, ensure a previous failed action is not blocking the current determination run. Pro tip: check for the SAP user parameter NDP no dialog printing. If this parameter is active on the user's ID, EWM may bypass the manual determination screen entirely and fail silently if a default printer is not pre-configured in the background.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 140. You have multiple pack stations sharing the same work center, but labels must print at the specific printer closest to the physical station. How do you configure printer determination based on the physical work center?
Answer: this is achieved by utilizing workcenter print profiles combined with bin-level mapping. I would implement this through 1. Define print profiles. Create individual print profiles for each physical packing bench. 2. Assign profile to work center or bin. In transaction/SCWM/TWORKST, assign the specific print profile to each physical storage bin or work center console. 3. Configure printer determination. In transaction/SCWM/PRT_DET printer determination, map the print profile and the packaging material type to the exact output device printer ID designated for that station. 4. Verify user-independent determination. Ensure that EWM's determination rules prioritize the storage bin or work center attribute over the user ID attribute in the access sequence. Pro tip: if you use virtual packing stations where operators log in from different PCs, configure the printer mapping using the terminal name obtained via the front-end network IP. This ensures that no matter who logs in, the labels print at the physical desk where the PC is sitting.
Scenario 141. A goods issue GI is posted, but the customer delivery note smart form fails to trigger, delaying the truck's departure. How do you resolve this post-GI printing failure?
Answer: this failure is usually related to incorrect PPF action triggers linked to status changes. I would troubleshoot the output failure by checking 1. Validate status-dependent PPF. Ensure that the PPF action for the delivery note is configured to trigger only when the goods issue status of the outbound delivery is set to completed. 2. Check SmartForm name assignment. Go to the output print configuration and verify that the correct SmartForm name is mapped to the PPF action and is active in the current client. 3. Test SmartForm in isolation. Run the SmartForm program manually in transaction SFP or SmartForms to verify there are no active coding syntax errors or unhandled exceptions, for example, division by 0 in the price field causing a runtime dump. 4. Verify spool processing. Check transaction SB01 to see if the spool was created, but is in error or waiting status due to a connection issue with the host spooler. Pro tip: always check transaction SD22 immediately after a post-GI print failure. If the SmartForm code crashes due to a null value in a custom field such as a customer-specific tariff code, the system will roll back the print action without updating the delivery logs.
Scenario 142. Management wants the final shipping label to print only when the pallet is loaded onto the truck, not when it is packed. How do you configure a delayed printing requirement?
Answer: this is managed by configuring status-dependent PPF actions. I would implement this delay through 1. Define custom PPF action. Create a new PPF action specifically for the final shipping label. 2. Set execution time to processing on save. Configure the action to trigger when the outbound delivery document is saved. 3. Configure schedule conditions. Assign a schedule condition class to the action that evaluates the loading status load of the delivery or transportation unit. 4. Set status validation. Ensure the condition class checks table/SCWM/PHDR to confirm the loading status is completed value 9 before allowing the action to transition from scheduled to released. Pro tip: if you are using yard management, you can link this trigger directly to the TU departure event. This ensures that the documentation only prints when the truck is physically checked out of the gate, preventing misplaced paperwork on the dock.
Scenario 143. The customer wants an automated shipping confirmation email with tracking numbers sent directly to their inbox the second the goods issue is completed. How do you configure this email notification?
Answer: this is achieved by configuring a PPF action with an external send processing type. I would execute the configuration as follows. 1. Configure PPF action medium. Create a PPF action in the outbound delivery profile and set the processing medium to external send email. 2. Verify SAP Connect SCOT configuration. Ensure that the SMTP server and Internet Mail Gateway are fully configured and functional in transaction SCOT. 3. Map recipient address. Configure the PPF action class to dynamically pull the email address from the ship-to-party business partner master data. 4. Use PDF attachment. Attach the generated delivery note SmartForm as a PDF to the outgoing email by configuring the PDF conversion settings in the action definition. Pro tip: implement a custom baddie inside your PPF processing class to query the tracking numbers from the shipping HUs. This allows you to dynamically populate the tracking links directly in the body of the system-generated email.
Category 12 Conclusion.
Mastering the post-processing framework, or PPF, is essential for keeping a warehouse moving. By fine-tuning print profiles, output determination, and status-dependent triggers, you ensure that the physical paperwork and labels are always exactly where they need to be, when they need to be there. This prevents paper bottlenecks and keeps shipping operations fluid.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 12 to Category 13.
While printing coordinates the physical actions on the warehouse floor, none of those actions can happen without a solid data foundation. EWM cannot operate in a vacuum. It relies entirely on a continuous, real-time handshake with the core ERP system. We now transition from printing outputs to the lifeline of warehouse communication. ERP integration. This is where we handle the master data and transactional pipelines that connect your warehouse to the broader enterprise. Let's explore Category 13.
Category 13. ERP integration scenarios.
ERP integration is the digital nervous system of SAP EWM. This category covers the critical data flows between SAP ERP or S/4HANA and EWM. You will face scenarios on delivery replication failures, stuck transactional queues, master data synchronization issues, and resolving stock discrepancies between the two ledgers. Mastering these integration points is essential for maintaining a reliable, real-time system.
Category 13. ERP integration scenarios.
Here are the 10 critical scenarios covered in this category. Scenario 144. Delivery not replicated from ERP to EWM. Scenario 145. Material master missing in EWM. Scenario 146. Business partner replication issue. Scenario 147. Queue stuck between ERP and EWM. Scenario 148. CIF inconsistency issue. Scenario 149. ERP stock and EWM stock mismatch. Scenario 150. Failed QRFC recovery. Scenario 151. Storage location mapped incorrectly. Scenario 152. Posting change not updating ERP. Scenario 153. ERP cancellation not reflected in EWM. Total 10 scenarios. Let's deep dive into Scenario 144.
Scenario 144. A critical customer order is created and saved in ERP, but the shipping office cannot find the delivery in EWM to begin picking, threatening a same-day shipping SLA. How do you troubleshoot and resolve this delivery replication failure?
Answer: this is typically an integration failure at the interface layer. I would troubleshoot and resolve the issue using the following steps. 1. Analyze QRFC monitor SMQ2. Check for stuck inbound queues in EWM to identify if the delivery is blocked by a technical lock, a data inconsistency, or a mapping error. 2. Validate warehousing SLOC configuration. Confirm that the ERP storage location is correctly mapped to the EWM warehouse number and the correct availability group in the integration settings. 3. Check delivery type and item category mapping. Ensure that the ERP delivery type and item category are assigned to an active EWM document type in the system mapping tables. 4. Verify partner and product replication. Confirm that the business partner for the ship-to-party and the warehouse product master are fully active, as missing master data will block replication. Pro tip: use transaction/SCWM/PRDI and look for the delivery in inactive status. Often the document is there but inactive because a validation check failed. Hitting the check button in the UI will reveal the exact missing field.
Scenario 145. A newly introduced SKU is received at the inbound dock, but EWM throws an error stating that the product does not exist in the warehouse, halting the receiving process for the entire shipment. How do you troubleshoot and resolve this missing product master data?
Answer: this occurs when the global product data is replicated, but the warehouse-specific master record is missing. I would resolve the issue using the following steps. 1. Verify ERP product replication. Confirm that the material master was successfully replicated from ERP via CIF or S/4HANA synchronization and is visible in EWM general views. 2. Check Product Master Warehouse Views. Open transaction/SCWM/MAT1 and verify if the specific warehouse number view is maintained for the product. 3. Validate UOM and packaging data. Ensure that the base unit of measure UOM and alternative UOMs are aligned with ERP to prevent unit of measure mapping errors during task creation. 4. Check inbound queues for CIF or ALE failures. Analyze transaction SMQ2 for failed queue messages related to the product master that may have blocked the replication of specific attributes. Pro tip: always automate the generation of the warehouse product master using the product warehouse view mass creation tool /SCWM/mat1_create or link it to your master data creation workflow. Simply replicating the global material master from ERP is not enough for EWM to execute tasks.
Scenario 146. A vendor shipment arrives, but the EWM inbound delivery fails to create because the vendor's business partner data is missing or out of sync in the warehouse system. How do you resolve this business partner replication failure?
Answer: this is caused by a failure to synchronize master data across systems. I would resolve the replication issue using the following steps. 1. Check BP transaction/SCWM/BP. Verify if the vendor's business partner record actually exists in EWM and that the General Data tab is active. 2. Verify ALE and IDOC and QRFC queues. Analyze transactions BD87 and SMQ2 for failed BUPA queues or IDOCs carrying business partner data from ERP. 3. Validate vendor and customer role assignment. Ensure that the business partner is assigned the mandatory FLVN01 supplier role in S/4HANA or the corresponding roles in EWM. 4. Check BP Identification tab configuration. Verify that the Identification tab contains the exact ERP vendor number mapped under the CRM00 for identification type, enabling the cross-system document match. Pro tip: in S/4HANA embedded EWM, business partners are synchronized automatically. However, if you are on a decentralized system, ensure that the BP replication is controlled via the DRF data replication framework, and that the filters are set to immediately send updates.
Scenario 147. An outbound shipment is fully confirmed and processed in the warehouse, but the transactional queue is stuck with a red error in SMQ1, preventing the inventory from being decremented in ERP. How do you identify, analyze, and clear this stuck integration queue?
Answer: a stuck queue indicates an update block in the target system. I would troubleshoot and resolve the issue using the following steps. 1. Analyze error text in SMQ1 and SMQ2. Double-click the status field in the QRFC monitor to read the explicit error message returned by the ERP update function. 2. Check for document and table locks. Run transaction SM12 in both ERP and EWM to see if another user or process is locking the delivery document or the material ledger tables. 3. Validate interface mapping and movement types. Ensure that the EWM stock type and the ERP storage location and movement type mappings are fully aligned in the configuration. 4. Manually reprocess the queue. Once the root cause is resolved, for example, clearing user locks or opening posting periods, select the queue and trigger a manual processing run. Pro tip: if a queue is stuck with a sysfail error due to a locked document, do not delete the queue. Clear the user lock in transaction SM12 in the target system first, then select the queue in SMQ2 and press F6 to re-execute safely.
Scenario 148. A warehouse is facing a master data synchronization inconsistency between ERP and S/4HANA and EWM, where active batch statuses are misaligned and causing outbound picking tasks to fail. How do you troubleshoot and resolve this synchronization gap across different deployment models?
Answer: resolving master data synchronization failures depends heavily on your specific deployment architecture. I would execute the following steps to realign the systems. 1. Identify the deployment architecture. Determine if the warehouse is running decentralized EWM, which uses CIF or DRF, or embedded EWM, where ERP and EWM operate within the same S/4HANA system, and therefore do not require CIF-based master data replication to isolate the communication channel. 2. Verify replication models CIF or DRF. For decentralized systems, check active integration models in transaction CFM2 for CIF or replication models in transaction DRF out for DRF to ensure batch replication is triggered. 3. Run stock and master data reconciliation. Execute transaction CFM2 comparison in ERP or /SCWM/C if_error_rec in EWM for CIF-based systems, and verify OData and IDOC queues for DRF-based systems. 4. Check embedded sync buffers. For embedded EWM, verify that the direct table updates such as table/SCWM/T331 or stock types are not blocked by a database lock or an unposted material document. Pro tip: for S/4HANA decentralized systems, transition from legacy CIF to DRF data replication framework. DRF uses outbound implementations that allow you to filter and replicate batch classifications instantly via SOA or ALE services, eliminating the performance overhead of classic CIF queues.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 149. A periodic inventory reconciliation reveals that the unrestricted use stock balance in the ERP system does not match the physical stock count registered in the EWM warehouse monitor, causing a major financial audit risk. How do you identify, analyze, and correct this inventory mismatch?
Answer: this stock mismatch indicates an interface posting delay, a stuck queue, or an uncleared discrepancy. I would resolve this by first running the stock comparison tool transaction /SCWM/ERP_stock check to isolate the exact discrepancies between EWM table /SCWM/QUOT and ERP table MARD. Next, I would audit the difference analyzer to see if warehouse adjustments are pending approval and check SMQ1 and SMQ2 for any failed posting changes. Once analyzed, I would post the approved differences to trigger the matching 711 and 712 movement types in ERP, fully aligning both ledgers. Pro tip: before posting stock corrections, ensure no warehouse tasks are in open status. An open task reserves stock logically in EWM, but is not yet posted to ERP, which is the #1 cause of false stock mismatches.
Scenario 150. A network interruption during a high-volume shift has caused hundreds of queue messages to fail simultaneously with an RFC error, and the automatic retry mechanism has stopped, paralyzing system communication. What is your recovery plan to restore communication and process these failed queues?
Answer: this requires resetting the queue RFC scheduler and clearing the background bottlenecks. I would execute the recovery using the following steps. 1. Check queue statuses in SMQ1 and SMQ2. Filter the queues by warehouse and document prefix to identify the exact point of the network failure. 2. Run queue recovery tool /scwm/queue recovery. Use this utility to identify and reprocess any out-of-sequence queue RFCs that failed during the downtime. 3. Analyze connection handshake via SM59. Test the RFC destination and the transactional RFC ports TRFC to confirm the network path is fully restored. 4. Schedule automatic queue restart jobs. Configure the queue RFC scheduler transaction SMQR to trigger an automatic retry for any queue holding a temporary retry status. Pro tip: configure the queue RFC scheduler transaction SMQR with an automatic retry limit and interval. This ensures the system attempts to heal and restart failed queues automatically without requiring manual supervisor intervention after a network drop.
Scenario 151. During a post-go-live check, you discover that inbound receipts are posting stock to the quality storage location in ERP instead of the unrestricted storage location due to a mapping mismatch. How do you correct this structural integration error?
Answer: this is caused by an incorrect alignment between availability groups and storage locations. I would correct the configuration using the following steps. 1. Check warehouse integration and S-lock mapping. Open the configuration for map storage locations from ERP system and inspect the current assignments. 2. Verify availability group assignments. Check if the EWM stock types, for example, F1 versus Q1, are mapped to the correct availability groups in the warehouse settings. 3. Correct storage location mapping. Update the mapping table to assign the correct ERP storage location to availability group 001 unrestricted. 4. Perform posting change to align stock types. Run transaction /scwm/im_PC to move any misposted stock to the correct storage location in the ERP system. Pro tip: during hypercare, if you find this error after stock has already been received, do not simply change the configuration. You must first perform a posting change transaction /scwm/im_PC to clear all physical inventory from the mismatched stock types. Otherwise, you will create permanent, unclearing stock inconsistencies.
Scenario 152. A quality inspector releases a batch from blocked to unrestricted in EWM, but the status update fails to reflect in the ERP system, allowing sales orders to remain blocked. How do you resolve this posting change synchronization failure?
Answer: this usually indicates an authorization, lock, or posting period issue in ERP. I would resolve the update failure using the following steps. 1. Check outbound queues in EWM SMQ1. Check if the stock transfer or posting change queue is stuck with a red error pointing to the ERP system. 2. Verify stock type and movement type mapping. Confirm that EWM stock type changes, for example, B2 to F2, are mapped to valid ERP movement types, for example, 343 in the EWM configuration. 3. Check ERP posting period configuration. Verify in transaction MMPV that the current posting period is open in the ERP system. 4. Re-execute posting change via /scwm/im_PC. If the queue can be cleared, re-trigger the message. If a system block exists, perform a manual reconciliation posting to align the stock. Pro tip: check if the ERP posting period transaction MMPV is open for the current date. If EWM attempts a posting change in a closed ERP period, the queue will fail in SMQ2 with a period closed error, requiring you to open the period and restart the queue.
Scenario 153. A customer cancels an order in ERP, and the sales team deletes the outbound delivery, but the corresponding outbound delivery request remains active in EWM, allowing pickers to continue collecting the stock. How do you resolve this cancellation synchronization failure?
Answer: this is caused by an inactive delivery cancellation flag or a queue block. I would resolve the synchronization failure using the following steps. 1. Verify queue status for document deletions. Check SMQ2 and EWM for any stuck outbound delivery change messages that have failed to process. 2. Check delivery change and cancellation WPT flags. In the EWM outbound delivery configuration, verify that the delete or cancel delivery flag is checked for the specific document type. 3. Validate document flow status in /SCWM/PRDO. Confirm if the picking warehouse tasks have already been created or confirmed. If picking is already in progress, EWM will reject the cancellation. 4. Manually adjust or reject the delivery in EWM. If the automated update fails, manually reject the delivery items in EWM using transaction /SCWM/PRDO to stop further execution. Pro tip: in the EWM delivery configuration, ensure the delete or cancel delivery flag is enabled for the specific item type. If this flag is inactive, EWM will reject the cancellation request from ERP and keep the warehouse tasks open.
Category 13 Conclusion.
Mastering the data exchange between ERP and EWM is the absolute baseline of warehouse stability. By resolving replication failures, managing queues, and maintaining inventory reconciliation, you ensure that the physical stock is always aligned with the financial ledger. This seamless core integration is what allows the business to scale with confidence.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 13 to Category 14.
Once the warehouse ledger is synchronized with the ERP core, we must look beyond our warehouse walls. Inventory does not arrive or depart on its own. It requires a coordinated transportation network. We now transition from internal data synchronization to the physical logistics network. Transportation management integration. This is where EWM shakes hands with TM to coordinate freight, vehicles, and dock schedules. Let's explore Category 14.
Category 14. TM Integration Scenarios.
Transportation management TM integration bridges the gap between warehousing and freight execution. This category covers both the traditional transportation unit TU-based model and the modern S/4HANA advanced shipping and receiving ASR framework. You will face scenarios on freight order integration failures, yard tracking, route-based waiving, and gate coordination.
Category 14. TM Integration Scenarios.
Here are the 7 critical scenarios covered in this category. Scenario 154. Freight order not integrated with EWM. Scenario 155. Loading appointment mismatch. Scenario 156. Transportation unit missing in yard process. Scenario 157. Staging area determination failing from TM data. Scenario 158. Shipment delay impacting warehouse processing. Scenario 159. Route-based wave release. Scenario 160. Vehicle check-in or check-out issue. Total 7 scenarios. Let's dive into Scenario 154.
Scenario 154. A freight order is planned and finalized in S/4HANA TM, but the shipping team in EWM cannot find any corresponding execution objects, blocking the yard gate and warehousing flow. How do you troubleshoot and resolve this integration failure?
Answer: this is typically an integration failure at the communication layer. I would troubleshoot and resolve the issue using the following steps. 1. Identify the integration model. Determine if the warehouse is running classic transportation unit TU-based integration via SOAP or LDAP services or modern S/4HANA advanced shipping and receiving ASR. 2. Verify XML SOAP message logs. Run transaction SRT_MONI or transaction SXMB_MONI to check for failed inbound and outbound XML messages between the TM and EWM modules. 3. Validate freight unit assignment. Confirm in the TM cockpit that the outbound delivery is correctly assigned to an active freight unit and mapped to the freight order. 4. Check transportation planning type. Verify in the ERP and S/4HANA delivery document that the transportation planning type is set to external for TM-led planning. Pro tip: in S/4HANA ASR, there is no EWM-TU or vehicle object. EWM uses the TM freight order FO directly as a single shared object. If the FO fails to replicate, check if the outbound delivery order is correctly linked to the TM freight unit in the database tables.
Scenario 155. A carrier arrives at the gate, but their booked appointment time in the TM dock appointment scheduling app does not match the actual arrival window, leading to staging area congestion. How do you resolve this loading appointment mismatch?
Answer: aligning the transport schedule with physical warehouse capacity requires immediate gate and door coordination. I would execute the following steps. 1. Check dock appointment scheduling DAS status. Access the DAS monitor to verify if the appointment is in checked-in or pending status and read the carrier details. 2. Update the freight order event. Update the actual arrival event in the S/4HANA TM freight order to record the carrier's real-time delay or early arrival. 3. Perform ad hoc door reassignment. In the EWM monitor, override the pre-planned door allocation and assign the truck to the next physically available door. 4. Trigger staging area priorities. Reroute the outbound staging warehouse tasks to the newly assigned door to prevent physical lane blockages. Pro tip: configure EWM to allow gate clerks to perform ad hoc door assignments on the RF during check-in. This dynamically overrides the TM DAS plan, preventing physical gate blockages and carrier wait time penalties.
Scenario 156. A decentralized system is expecting a classic EWM transportation unit TU to be created from the TM freight order to initiate yard check-in, but the TU is missing, blocking the yard shunter. How do you troubleshoot and resolve this missing transportation unit?
Answer: this indicates a failure in the classic TU integration handshake. I would resolve the issue using the following steps. 1. Check TU generation monitor. Verify in transaction/SCWM/TU if the TU was generated manually or if the system failed during the automatic background run. 2. Inspect queue message updates. Check transaction SMQ2 for failed queue messages of type /SCWM/T transportation unit update that may have blocked the creation. 3. Verify PPF action for TU creation. Check if the PPF action for automatic TU creation based on the TM freight order message is assigned and active. 4. Trigger manual TU creation. If the automated update fails during a high-volume shift, manually create the EWM-TU using the TM freight order number as the reference to unblock the gate. Pro tip: in S/4HANA Advanced Shipping and Receiving ASR, The traditional EWM transportation unit plays a significantly reduced role because transportation execution is centered around the TM freight order. In ASR-driven processes, check-in, check-out, loading, and execution activities are typically managed directly against the freight order, reducing dependency on the classic EWM-TU-centric integration model.
Scenario 157. Outbound tasks are being created, but the staging area determination fails because EWM cannot read the route or door data transmitted from the TM freight order. How do you resolve this determination failure?
Answer: this is caused by an attribute mapping gap between the TM freight order and EWM staging rules. I would resolve the failure using the following steps. 1. Validate route and carrier mapping. Ensure that the TM route and carrier ID are correctly mapped to their corresponding EWM master data fields. 2. Verify staging area determination table. Check transaction/SCWM/status _out to confirm that the combination of warehouse number and TM route points to a valid staging area and bin. 3. Check TM data transmission payload. Inspect the inbound XML payload and SRT_MONI to verify if the door or staging bin ID is actually being sent by TM. 4. Analyze task creation logic. Run the warehouse task creation in debug mode using /SCWM/ to _create to identify why the determination logic is failing to resolve the target staging bin. Pro tip: in S/4HANA ASR, use transaction/SCWM/status_ASR. It is designed specifically to determine staging bins directly from TM freight order attributes like shipping point carrier and destination, bypassing old route-only rules.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 158. A major weather event has delayed an outbound carrier by 6 hours, but EWM has already picked and staged the entire 20-pallet load, creating severe lane congestion. How do you manage this delay-induced bottleneck?
Answer: managing real-time transport disruptions requires dynamic staging reallocation and status updates. I would execute the following steps. 1. Monitor freight order status. Check the real-time update in TM or Event Manager to verify the carrier's estimated time of arrival ETA. 2. Reroute staged handling units. Create ad hoc internal warehouse tasks to move the staged pallets from the dock door to an overflow or high-level holding bin. 3. Update wave staging prioritization. Adjust the priorities of other open waves to utilize the newly freed physical dock door for on-time carriers. 4. Re-trigger loading tasks on arrival. Once the delayed carrier finally checks in at the gate, regenerate the loading tasks to move the HUs from the holding bin back to the dock. Pro tip: configure EWM to subscribe to TM Event Manager alerts. When a transport delay of more than 2 hours is reported, the system can automatically block wave release for subsequent tasks on that route, protecting staging capacity.
Scenario 159. The warehouse manager wants waves to release automatically only when the TM freight order has achieved planned status, preventing pickers from staging stock too early. How do you implement this route-based wave release?
Answer: this is achieved by linking wave templates to the TM planning status. I would configure the process as follows. 1. Configure wave template release. Set the release method in the wave template to manual or event-driven. 2. Map TM planning status to PPF. Create a PPF action in EWM that is triggered by the planned or ready for execution status change in the TM freight order. 3. Verify route synchronization. Ensure that the TM route matches the EWM wave route to guarantee the correct deliveries are included in the wave. 4. Trigger automated wave release. Configure the PPF class to automatically release the corresponding wave the moment the TM status update is received. Pro tip: in S/4HANA ASR, you can link wave release to the execution status of the TM freight order. When TM sets the status to released for execution, EWM automatically triggers the wave, ensuring tight, real-time alignment.
Scenario 160. A trailer is fully loaded and ready to depart, but the gate clerk cannot post departure from checkpoint in EWM because the TM status is locked, blocking the truck. How do you resolve this vehicle check-in or check-out issue?
Answer: this indicates a status desynchronization between the EWM loading status and the TM freight order execution status. I would resolve the block using the following steps. 1. Verify EWM loading status. Confirm that all outbound delivery items have been successfully goods issued and that the EWM loading status is completed. 2. Check integration queues for locks. Open transaction SMQ2 and SMQ1 and check for failed queues that are trying to synchronize the loading completed status back to TM. 3. Inspect TM freight order execution status. Open the freight order in TM and verify if a manual lock has been set or if the status was incorrectly set to departed before the EWM confirmation. 4. Perform administrative checkout override. If the queues are cleared but the sync remains blocked, perform an administrative checkout override in EWM to allow the physical truck to depart. Pro tip: in advanced shipping and receiving ASR, use the Fiori app yard execution or shipping and receiving gate to post check-in and check-out. It communicates synchronously with TM, reducing the risk of locking queues at the gate.
Category 14 Conclusion.
Integrating transportation management with EWM is the key to synchronizing your warehouse activities with external carriers. Whether utilizing traditional transportation units or the next-generation S/4HANA Advanced Shipping and Receiving Framework, a seamless TM and EWM integration ensures that staging lanes are optimized, vehicle check-ins are fluid, and loading status updates are published in real time.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 14 to Category 15.
Coordinating transportation data across systems is highly important, but once those trucks physically arrive on your property, they must be managed inside your terminal. You cannot have carriers parking randomly or blocking your dock doors. We now transition from shipping and freight integration to the physical coordination of your terminal space. Yard management. This is where we control the real-time movement, parking, and door positioning of trailers and shipping containers. Let's explore Category 15.
Category 15. Yard management scenarios.
Yard management extends EWM's control beyond the warehouse walls into the physical yard. This category covers trailer check-in or check-out, yard bin mapping, shunter task execution, and gate-to-gate tracking. You will solve scenarios involving unannounced arrivals, mechanical dock failures, yard task failures, and demurrage cost optimization.
Category 15. Yard management scenarios.
Here are the 7 critical scenarios covered in this category. Scenario 161, vehicle arrives without appointment. Scenario 162, dock door reassignment required. Scenario 163, yard task not created automatically. Scenario 164, truck waiting time optimization. Scenario 165, yard bin determination issue. Scenario 166, gate-to-gate tracking requirement. Scenario 167, vehicle departure blocked due to incomplete loading. Total 7 scenarios. Let's dive into Scenario 161.
Scenario 161. A carrier arrives at the gate checkpoint with a full load, but the gate clerk finds no dock appointment or transportation unit scheduled in EWM and TM. Turning the truck away will disrupt the supplier relationship, but letting it in without a plan risks blocking the yard. How do you manage this unannounced arrival?
Answer. This requires an ad hoc check-in process combined with gate prioritization. I would instruct the gate clerk to create an ad hoc transportation unit TU or a manual freight order directly at the checkpoint using the carrier's physical weighable data. Instead of assigning a direct dock door, the truck must be checked in and routed to a generic yard parking bin to keep the active dock doors free. EWM will then generate a temporary staging request, allowing the yard planner to schedule a door slot later when a standard carrier slot opens or a planned truck is delayed. Pro tip. In S/4HANA Advanced Shipping and Receiving ASR, you can use the Fiori app shipping and receiving gate to quickly check in an unannounced truck. You can create a local freight order on the spot, link the inbound delivery, and send the driver to a designated unplanned parking area, ensuring complete physical and digital tracking.
Scenario 162. A trailer is partially unloaded at dock door 5 when the door's automatic leveling ramp suffers a mechanical failure, rendering the door completely unusable. The remaining 15 pallets must be unloaded immediately. How do you execute a dock door reassignment in the system?
Answer. This is resolved by performing a manual door reassignment and updating the open tasks. I would execute the following steps. 1. Lock the broken dock door. Set the inbound and outbound block flag on the storage bin representing dock door 5 to prevent any future assignments. 2. Reassign the TU or freight order. In the warehouse monitor under Yard Management, select the Active Transportation Unit or ASR freight order and change its assigned door to an open, functional door, for example, door 6. 3. Cancel and regenerate open tasks. Cancel any remaining waiting warehouse tasks associated with door 5. 4. Create yard task for trailer move. Generate a yard task for the shunter to physically move the trailer from door 5 to door 6, and once confirmed, trigger the new unloading tasks for the new door. Pro tip. Use transaction/SCWM/yard_bin to quickly check the occupancy of adjacent doors. When reassigning a door during a mechanical failure, always choose a door in the same activity area to ensure the same picking or unloading resources can continue their work without traveling to a different zone.
Scenario 163. A yard coordinator assigns a checked-in trailer to a dock door, but the system fails to generate the yard task for the shunter to move the vehicle from parking to the door, stalling the unloading plan. How do you troubleshoot this automatic yard task creation failure?
Answer: this usually indicates a failure in PPF action execution or queue processing. I would investigate the issue using the following steps. 1. Check PPF action log. Open the transportation unit TU or freight order in the monitor and inspect the yard movement PPF action or the equivalent customer-specific yard execution trigger. Verify whether the action is in red or error status and review the application log for determination or execution failures. 2. Verify shunter queue assignment. Ensure the yard movement task is correctly mapped to the yard shunter queue, usually yard in transaction/SCWM/QDET_out. 3. Check yard bin status. Confirm that the target dock door bin and the source parking bin are not blocked or locked by an active physical inventory document. 4. Validate resource logging. Verify that at least one shunter resource tugger is actively logged into the yard queue on their RF device to receive the task. Pro tip: if the PPF action fails with a determination error, verify the control activity configuration in the yard process type. If the system cannot find a valid path between the parking spot and the door, it will fail to generate the task.
Scenario 164. Demurrage fees are skyrocketing because trailers are sitting in the yard for an average of 4 hours before being called to a door, while warehouse crews are frequently idle. How do you optimize truck waiting time and yard throughput?
Answer: this requires transitioning from a reactive yard to a pull-based execution model using labor management and yard integration. I would implement dynamic queue prioritization, where EWM automatically calculates the age of a checked-in trailer at the gate. If a truck's waiting time approaches a critical threshold, for example, 90 minutes, the system escalates its priority. Additionally, we must link EWM's warehouse task queues with the shunter queues so that as soon as an unloading crew completes a door, the system automatically dispatches a yard task to the shunter to bring the next longest waiting trailer on that route. Pro tip: implement KPI dashboard monitoring using the warehouse monitor. Configure alerts for TU wait time and door idle time. This gives the yard supervisor a real-time heat map of yard congestion, allowing them to proactively reallocate shunt resources before demurrage penalties are triggered.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 165. A shunter attempts to check in a trailer, but the RF screen displays a yard bin determination failed error, preventing them from recording the trailer's physical parking spot. How do you resolve this yard bin determination failure?
Answer: this is caused by a missing link in the yard structure or parking zone mapping. I would resolve the issue using the following steps. 1. Verify yard bin configuration. Check transaction/scwm/yard_bin to ensure that the physical parking space is correctly defined as a storage bin under the yard storage type. 2. Validate storage section search. Ensure the yard storage type has storage section check active and that the bin belongs to an active parking section. 3. Check activity area mapping. Verify that the yard bins are assigned to a sorted yard activity area to enable system-guided task generation. 4. Verify TU and vehicle type mappings. Ensure the vehicle type, for example, 20 feet container versus 53 feet trailer, matches the bin type capacity. If the trailer is too large for the suggested parking bin, determination will fail. Pro tip: ensure the yard storage type has the put-away strategy set to empty bin or manual entry. If set to next empty bin and the network is down, the shunter cannot override the bin on their RF, causing a complete gate blockage.
Scenario 166. A manufacturing facility requires strict auditing of all trailer movements from the moment they enter the gate, through parking and loading, to the final checkout, to comply with security regulations. How do you configure complete gate-to-gate tracking?
Answer: this is accomplished by configuring a multi-step yard execution process that tracks check-in, parking, door assignment, loading, and checkout activities. I would implement the tracking as follows. 1. Define yard storage steps. Configure a yard storage process with steps for check-in CHKI, yard movement YMove, loading load, and checkout CHKO. 2. Map yard bins to gate and door. Define specific storage bins of type gate for checkpoints, parking for yard spots, and door for dock positions. 3. Enable automatic event logging. Configure the PPF framework to automatically log a status event, for example, arrived, parked, loading, departed at each task confirmation. 4. Verify audit trail and monitor. Use the EWM warehouse monitor's yard history node to view the timestamp path of every vehicle that has entered the facility. Pro tip: integrate EWM yard management with S/4HANA TM event status tracking. This allows external customer service teams to see the exact real-time gate-to-gate status of a shipment directly from their ERP sales order screens.
Scenario 167. A truck driver is ready to check out, but the gate clerk is blocked from posting departure from checkpoint because EWM throws an error stating that the vehicle's loading is incomplete, even though the physical trailer is completely loaded. How do you troubleshoot and unblock this departure?
Answer: this block occurs when there is a mismatch between physical execution and the system status of the delivery or TU. I would resolve the block using the following steps. 1. Check open loading tasks. In the warehouse monitor under active tasks, verify if there are any unconfirmed or waiting loading tasks associated with the TU or freight order. 2. Verify goods issue status. Confirm that all outbound delivery items assigned to the vehicle have achieved goods issue posted status. An unposted GI will block checkout. 3. Cancel ghost items. If an item was short shipped but the delivery quantity was not adjusted, cancel the remaining quantity or split the delivery to close the open items. 4. Perform force checkout. If a technical glitch is suspected and the physical truck must leave, use the Set Status button in the TU monitor to manually force the loading completed status. Pro tip: check for nested HUs that haven't been scanned. Often, the main pallet is scanned as loaded, but a nested child HU is left in packed status in the system, which causes the entire TU loading check to fail.
Category 15 Conclusion.
Mastering yard management is what connects your physical terminal logistics with internal warehouse execution. By enforcing structured gate-to-gate tracking, dynamic dock door assignments, and optimized shunter tasks, you eliminate yard congestion and minimize demurrage costs. A highly integrated yard is the key to achieving fluid warehouse intake and dispatch.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 15 to Category 16.
Once containers and trailers are efficiently checked in at your dock doors, the physical processing of stock begins. In a modern high-volume fulfillment center, we cannot rely solely on manual labor to move thousands of pallets per hour. We must hand over execution to high-speed automation. We now transition from yard logistics to the world of heavy industrial automation. Material Flow System, MFS. This is where EWM speaks directly to PLC-controlled cranes, conveyors, and sorting systems. Let's explore Category 16.
Category 16. MFS and Automation Scenarios.
The Material Flow System, MFS, is the programmatic bridge between EWM and warehouse automation hardware. This category covers the complexities of PLC communication, PLC telegram structures, ASRS crane handling, diverter routing, and performance tuning. You will face scenarios on communication drops, stuck conveyor tasks, and implementing emergency manual workarounds during automation failures.
Category 16. MFS and Automation Scenarios.
Here are the 8 critical scenarios covered in this category. Scenario 168. Conveyor task stuck in communication layer. Scenario 169. PLC communication failure. Scenario 170. Automated bin confirmation missing. Scenario 171. ASRS storage failure handling. Scenario 172. Diverter routing issue. Scenario 173. Manual intervention during automation failure. Scenario 174. Telegram communication inconsistency. Scenario 175. Automated warehouse performance bottleneck. Total 8 scenarios. Let's dive into Scenario 168.
Scenario 168. A pallet is on the physical conveyor, but the EWM-MFS task is stuck in send status, and no movement telegram is being acknowledged by the PLC, halting the line. How do you troubleshoot and resolve this technical bottleneck?
Answer: this indicates a breakdown in the TCP/IP communication or the telegram processing layer. I would troubleshoot and resolve the issue using the following steps. 1. Analyze telegram buffer. Check the MFS telegram buffer in the warehouse monitor under the MFS node to see if the message is stuck or unacknowledged. 2. Verify MFS communication channel. Check the active MFS communication channel and TCP/IP socket connection between EWM and the PLC. Confirm that the communication channel is online, reachable, and accepting telegram traffic. 3. Inspect handshake configuration. Confirm if the PLC is sending the expected receipt acknowledgement telegram ACK for the outgoing message. 4. Execute manual send retry. If the connection is verified, trigger a manual send retry or force confirm the telegram in the monitor to push the task to the next segment. Pro tip: check if the sequence number of the outgoing telegram has jumped out of sync. PLC communication protocols require strict sequential numbering, for example, 0001, 0002. If a packet was dropped, the PLC will ignore all subsequent telegrams until the sequence is reset in EWM.
Scenario 169. A major network drop causes all EWM-MFS connections to a critical PLC to fail simultaneously, shutting down an entire automated picking zone. How do you systematically troubleshoot and restore the connection?
Answer: restoring complete system communication requires a structured network and application diagnostic. I would execute the troubleshooting as follows. 1. Verify socket server status. Check transaction/scwm/mfs_PLC to verify if the communication channels are active and listening. 2. Run network gateway ping. Execute a ping test to the PLC's physical IP address and check the gateway port connectivity to confirm the network path is open. 3. Analyze gateway threads. Inspect transaction SMGW gateway monitor to check for failed RFC or TCP IP communication threads. 4. Trigger manual channel reconnect. Use the warehouse monitor to manually stop and restart the MFS communication channels to re-establish the connection. Pro tip: configure LifeBeat telegrams heartbeats in the MFS PLC settings. By setting EWM to send a ping telegram every 5 seconds, the system can automatically detect a silent connection drop and re-initialize the TCP IP socket before tasks start failing.
Scenario 170. An ASRS crane physically places a pallet into a high bay bin, but the final confirmation telegram is missing in EWM, leaving the stock logically stuck in transit status. How do you resolve this missing confirmation?
Answer: resolving missing confirmations requires auditing the incoming queue and telegram logs. I would troubleshoot the issue using the following steps. 1. Check incoming MFS telegram monitor. Review the inbound MFS telegram monitor and application logs for unprocessed, rejected, or failed confirmation telegrams that may have prevented the warehouse task from being updated. 2. Inspect telegram coordinates. Audit the telegram structure to see if the PLC transmitted an incorrect destination bin coordinate that EWM failed to resolve. 3. Verify SMQ2 inbound queues. Check the inbound RFC queues for blocked messages of type /SCWM/MFS that may contain the confirmation data. 4. Force confirm the warehouse task. If the physical pallet placement is verified by the floor team, manually confirm the warehouse task in the monitor to update the logical stock. Pro tip: always map a fallback bin in the MFS configuration. If the PLC transmits a bin coordinate that EWM cannot resolve, the system should post the stock to the fallback bin rather than failing silently, ensuring the stock remains visible and searchable.
Scenario 171. An ASRS crane attempts to place a pallet, but EWM receives a bin occupied or double storage error from the crane's onboard sensors, blocking the crane. How do you configure and handle this physical storage exception?
Answer: handling physical storage conflicts requires a dynamic exception and rerouting workflow. I would configure and execute the process as follows. 1. Verify incoming exception code. Inspect the incoming error telegram, for example, bin_occupied transmitted by the crane PLC to identify the trigger. 2. Trigger EWM exception MFS_double. Map the PLC error code to EWM exception code MFS_double to automatically intercept the task execution. 3. Generate rerouting warehouse task. Configure an automated exception workflow to cancel the original put-away task and generate a follow-on warehouse task to a clearance or exception bin. 4. Create automatic inventory document. Configure the system to automatically trigger a physical inventory PI document for the blocked bin to force a recount of the phantom stock. Pro tip: implement active bin verification. Configure the system to automatically block the occupied bin for put away while leaving it open for picking, allowing the warehouse to naturally consume the phantom stock and clear the error without manual inventory stops.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 172. Pallets are consistently being sent to the reject lane because the conveyor diverter PLC is receiving a no routing found message from EWM's MFS engine. How do you correct this routing configuration?
Answer: this is caused by a disconnect in the logical MFS routing or task status. I would troubleshoot and correct the configuration using the following steps. 1. Check MFS routing table. Verify that a valid path is defined between the current decision point and the final destination in the MFS routing configuration. 2. Inspect barcode scan telegram. Check /scwm/MFS_tele to confirm that the PLC is transmitting a clean, readable HUID without garbage characters. 3. Verify warehouse task status. Ensure that the warehouse task for the pallet actually exists and is in active status. If the task is blocked, MFS cannot determine a path. 4. Validate LOSC alignment. Ensure the physical layout-oriented storage control LOSC configuration is fully aligned with the logical MFS decision points. Pro tip: use default routing at decision points. If EWM cannot find a specific path for a pallet, the routing engine should direct it to a central clearing station rather than the scrap or reject lane, saving physical handling time.
Scenario 173. A major mechanical failure shuts down your ASRS cranes for projected 8 hours during a peak shift. You must switch to manual reach trucks immediately to fulfill orders, but you must prevent duplicate confirmations or ghost inventory. How do you manage this manual fallback?
Answer: this requires executing an emergency automation bypass protocol in EWM. First, I would use the warehouse monitor to temporarily block the MFS communication channels to prevent the system from sending any new tasks to the PLCs. I would then use the task reassignment function in /scwm/mon to mass cancel all open MFS tasks and reassign the inventory to a manual activity area. By changing the warehouse process type to a manual forklift profile, the system will immediately generate standard picking tasks visible on the RF handhelds, allowing manual reach trucks to bypass the cranes and pull stock directly from the lower racks while keeping inventory records fully synchronized. Pro tip: prepare fallback resource groups in advance. Have a pre-configured manual_reach profile in EWM. When automation drops, you can change the WPT assignments in less than 5 minutes ensuring your floor crew can transition to manual picking without waiting for custom development or system restarts.
Scenario 174. The conveyor PLC and EWM are connected, but some telegrams are being silently dropped or processed out of order, causing pallets to collide or stop on the line. How do you troubleshoot this telegram inconsistency?
Answer: this is resolved by checking the telegram sequence and socket buffer settings. I would troubleshoot using the following steps. 1. Check telegram sequence numbers. Compare the sequence number of sent and received telegrams in transaction/SCWM/MFS_tele for any gaps or duplicate IDs. 2. Verify timeout parameters. Confirm that the TCP/IP keep alive and telegram acknowledgement timeout parameters are matched between EWM and the PLC settings. 3. Review serialization settings. Verify the serialization settings in the MFS connection profile to ensure EWM processes incoming telegrams sequentially FIFO. 4. Analyze network packet logs. Check the ERP gateway or web dispatcher logs for network packet loss or socket buffer overflows during high-volume spikes. Pro tip: enable temporary MFS debug tracing and detailed telegram logging during the incident window. Capturing the complete telegram sequence and communication flow helps determine whether the issue originates from SAP EWM processing, PLC behavior, or the underlying network infrastructure.
Scenario 175. EWM is generating tasks, but the physical conveyor line is backing up, and ASRS cranes are sitting idle, creating a severe performance bottleneck. How do you identify the root cause and optimize the MFS system throughput?
Answer: this is a classic throttling and capacity optimization challenge. I would use the EWM-MFS resource monitor to analyze the task dispatching rates. Often, the bottleneck is not the hardware, but EWM send buffer or max tasks per resource setting being too restrictive, causing the system to hold back tasks even when the physical crane is empty. I would optimize this by increasing the maximum number of tasks allowed on the MFS communication channel and adjusting the dwell time settings. This allows EWM to stream multiple telegrams to the PLC buffer in advance, keeping the cranes in continuous motion and maximizing physical throughput. Pro tip: implement look-ahead routing. Configure EWM-MFS to evaluate the next 3 steps in the layout-oriented storage control LOSC sequence. If the system detects a bottleneck at a downstream decision point like a scale or wrapping station, it can dynamically hold back tasks at the source bin, preventing conveyor line locks.
Category 16 Conclusion.
Mastering the material flow system, or MFS, is what separates standard warehouse execution from world-class high-speed automation. By fine-tuning TCP/IP sockets, telegram sequence serialization, and automating ASRS crane exception handling, you ensure that physical automation and EWM's logical ledger work in perfect, millisecond-level harmony.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The Elite Transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 16 to Category 17.
No matter how advanced your automated cranes or how precise your integrated transportation routes are, the physical reality of a warehouse is unpredictable. Pallets break, barcodes get smudged, and orders get canceled at the absolute last second. To prevent these inevitable real-world disruptions from stopping your operations, you must master the art of deviation management. We now transition from high-speed automation to the front lines of problem-solving. Exception handling. Let's explore Category 17.
Category 17. Exception handling scenarios.
Exception handling is where a consultant proves their real-world troubleshooting worth. This category covers the critical processes for resolving physical-to-system mismatches, lost handling units, unexpected stock discoveries, and late-stage order cancellations. These scenarios test your ability to configure robust exception codes, manage reverse logistics, and restore system balance when warehouse operations deviate from the planned path.
Category 17. Exception handling scenarios.
Here are the 10 critical scenarios covered in this category. Scenario 176. Picker found damaged stock during picking. Scenario 177. HU lost during internal movement. Scenario 178. Wrong product picked accidentally. Scenario 179. Stock found in wrong bin. Scenario 180. WT partially confirmed. Scenario 181. Negative stock situation. Scenario 182. Delivery canceled after picking completion. Scenario 183. Customer rejects shipment after GI. Scenario 184. Resource confirms incorrect quantity. Scenario 185. Emergency stock transfer requirement. Total 10 scenarios. Let's dive into Scenario 176.
Scenario 176. A picker is directed to a bin to retrieve 10 units of a high-value product, but they discover that 5 of the physical units are water-damaged and cannot be shipped. The customer order must still be fulfilled on time. How do you resolve this exception in the system?
Answer: this requires immediate exception handling to record the damage and trigger a replenishment. I would execute the following steps. 1. Apply exception code diff. Confirm the 5 undamaged units and enter 5 as a difference using the diff exception code on the RF device. 2. Direct difference posting. Configure the diff code to automatically post the 5 damaged units to the difference analyzer, which clears the physical bin immediately. 3. Trigger picking pick denial. Allow EWM to immediately trigger a pick denial bidden to search for the remaining 5 units in an alternative storage bin. 4. Relocate damaged stock. Create an ad hoc warehouse task to physically move the 5 damaged units to a quarantined inspection storage type. Pro tip: to automate this completely, map the diff exception code to a follow-on action that dynamically changes the stock type of the discrepant quantity to blocked B2 or B6 as soon as it is reported. This prevents other pickers from being guided to the damaged stock before a supervisor can physically move it.
Scenario 177. A forklift driver was tasked with moving an HU from the deconsolidation station to a high bay rack, but they dropped and lost track of the physical pallet. The HU still shows as in transit in the system, blocking other inventory movements. How do you troubleshoot and resolve this lost HU?
Answer: resolving a lost in transit HU requires releasing the system locks and adjusting the inventory. I would execute the following steps. 1. Locate system footprint and monitor. Use the warehouse monitor's HU history node to find the last confirmed location and the active warehouse task ID. 2. Cancel open movement task. Cancel the open warehouse task if unconfirmed to release any logical locks on the delivery or product. 3. Post HU to lost and found zone. Use transaction/scwm/adhu to manually move the logical HU to a virtual lost and found storage type such as 9015 to clear the active zone. 4. Execute physical inventory count. Trigger an ad hoc physical inventory document for the source and target bins to reconcile the physical inventory and document the stock adjustment. Pro tip: never simply delete a lost HU. If you delete it, you destroy the transactional history and serial number tracking. Moving it to a lost and found virtual storage type keeps the HU history alive, allowing you to easily re-find and reactivate it if it turns up in a different aisle later.
Scenario 178. A picker inadvertently picks and scans a similar-looking but incorrect product, confirms the task on the RF, and sends the HU to the packing station. The mistake is caught during the final packing check. How do you correct this physical and digital mismatch?
Answer: correcting this mismatch requires reversing the picking task and returning the incorrect stock. I would execute the following steps. 1. Reverse the confirmed picking task. In the warehouse monitor, locate the confirmed picking task and execute the reverse confirmation or cancel pick method. 2. Return stock to source bin. EWM will automatically generate a return transfer warehouse task to move the incorrectly picked product from the packing station back to its original storage bin. 3. Block the incorrect stock. Put a temporary unplanned PI or manual block on the source bin to investigate why the wrong product was stored there. 4. Regenerate picking task for correct product. Re-release the delivery item to create a new warehouse task guiding the picker to the correct product. Pro tip: implement scan verification profiles at the packing station. By forcing a barcode scan of the product's EAN or UPC at the packing station, you create a fail-safe check. EWM will block the packing process immediately if the scanned product does not match the outbound delivery item, catching the error before shipment.
Scenario 179. A picker physically finds a pallet of fast-moving products sitting in a bin that EWM system registers as completely empty. How do you bring this found stock into the inventory ledger without corrupting your audit trail?
Answer: bringing found stock into EWM requires a formal inventory adjustment rather than a simple movement task. I would execute the following steps. 1. Create ad hoc physical inventory document. Generate an ad hoc PI document transaction /SCWM/PI_ create specifically for the bin where the stock was found. 2. Perform blind count entry. Enter the physical count batch and HU details into the PI document on the RF device. 3. Analyze difference in difference analyzer. Post the difference in /SCWM/diff_analyzer, which registers as a stock gain in EWM. 4. Reconcile and clear to ERP. Clear the differences to ERP to post a goods receipt for physical inventory gain movement type 711 and 712. Pro tip: do not use simple ad hoc warehouse tasks like /SCWM/add_prod to move found stock. Moving found stock via a standard task without a PI document bypasses the difference analyzer and can lead to major valuation and tax compliance issues during financial audits.
Scenario 180. A warehouse task was created for a full pallet of 100 units, but during physical execution, the forklift driver could only fit 80 units on their vehicle due to space constraints, resulting in a partial confirmation. How do you process this partial WT confirmation?
Answer: handling partial capacity moves requires executing a task split during confirmation. I would execute the process as follows. 1. Enter split quantity on RF. During confirmation, change the confirmed quantity to 80 and select the SBLT split exception code. 2. System Guided Task Split. EWM will immediately confirm the 80 units to the target destination and split the remaining 20 units into a new open warehouse task. 3. Validate status of remaining quantity. Check if the new 20-unit task should be assigned to a different queue or executed by a different resource. 4. Check outbound delivery status. Ensure the outbound delivery reflects the partial confirmation and updates the picking status to partially completed. Pro tip: ensure your WOCR limits are aligned with your vehicle capacity. If partial confirmations are happening frequently due to space constraints, it indicates that the system is grouping too many tasks into a single warehouse order. Adjusting the WOCR volume limits will prevent these manual splits.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, They all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 181. A system timing lag has allowed a picking task to be confirmed before the inbound put-away task was fully registered, resulting in a negative stock of -10 units in the picking bin. How do you troubleshoot and correct this negative stock situation?
Answer: correcting negative stock requires identifying the sequence mismatch and posting the lagging transactions. I would troubleshoot the issue as follows. 1. Identify the out-of-sequence postings. Use the warehouse monitor's stock and bin node to compare the timestamps of the confirmed put-away task and the picking task. 2. Verify storage type configuration. Check the storage type configuration, for example, the negative stock settings maintained in the storage type definition to see if negative stock is permitted. 3. Check for stuck integration queues. Analyze SMQ2 for any failed inbound delivery confirmations that should have posted the stock before the pick occurred. 4. Repost the inbound and put-away task. Confirm the pending inbound put-away task to EWM, which will immediately offset the negative balance and return the bin to a positive quantity. Pro tip: never allow negative stock in racking or bulk storage types. Negative stock should only be enabled in virtual transit or staging zones like 9010 or 9020 to keep the shipment moving during timing discrepancies. Allowing it in physical racking will corrupt your bin capacity and slotting logic.
Scenario 182. A customer cancels a massive sales order at the absolute last second, just as the picked and packed pallets are staged at the dock door. The truck is not coming, and 20 custom packed pallets are blocking your shipping lane. How do you manage this late-stage delivery cancellation and return the stock?
Answer: this requires a coordinated reversal of pick and return to stock process. First, I would use transaction/SCWM/PRDO to accept the cancellation from ERP, which changes the delivery status in EWM to canceled and blocks the goods issue. I would then use the return to stock process available in the warehouse monitor to evaluate the picked HUs and generate follow-on put-away tasks. This allows the system to automatically assign them from the canceled delivery and route the pallets either back to their original reserve bins or to a deconsolidation station to be unpacked and returned to the pick face, keeping the inventory perfectly synchronized. Pro tip: do not unpack the pallets at the dock. This creates severe floor congestion. Instead, keep the picked HUs intact. Use the return to stock process to generate system-guided tasks to move the entire HU to an intermediate storage area and perform the unpacking and restocking there under controlled conditions.
Scenario 183. An outbound truck has left the facility and goods issue GI has been posted, but the customer rejects the shipment at their receiving dock due to a temperature deviation. The truck returns to your warehouse with the full load. How do you handle this reverse logistics exception?
Answer: this requires a goods issue reversal or a returns inbound delivery process, depending on the financial state. Since the truck has physically returned with the goods, the cleanest method is to execute the standard goods issue reversal process in EWM to reverse the GI posting, which automatically updates the ERP delivery status back to picked. I would then generate return to stock warehouse tasks to move the pallets back into the warehouse for inspection. If the financial billing has already been finalized in ERP, I would instruct the customer service team to create an advanced returns management ARM inbound delivery, treating the returning truck as an inbound shipment to ensure a clean audit and tax trail. Pro tip: always check the batch status during a return. Since the shipment was rejected due to a temperature deviation, you must use an exception code during the return GR that automatically changes the stock type of the batch to blocked or quality Q3 or B3, preventing it from being accidentally picked for another customer before quality testing is complete.
Scenario 184. A picker accidentally confirms a task for 100 units on their RF device when they physically only picked 10 units, and the mistake is only realized after the delivery is closed. How do you correct this confirmed quantity error?
Answer: correcting an overconfirmation error requires a physical count and a manual adjustment in the difference analyzer. I would execute the process as follows. 1. Reopen the closed delivery. If goods issue has not been posted, use /SCWM/PRDO to adjust the picking quantity of the delivery item back to 10. 2. Audit difference analyzer. EWM will automatically post the 90 unit over confirmation discrepancy to the difference analyzer as a logical loss. 3. Post difference to align stock. Approve the 90 unit loss in /SCWM/diff_analyzer to update the physical EWM bin and trigger the matching correction in ERP. 4. Perform physical recount. Generate an ad hoc PI document for the picker's source bin to verify if the 90 units are physically still in the rack. Pro tip: implement RF confirmation thresholds. You can configure EWM to require a supervisor's password if an RF user attempts to confirm a quantity that deviates by more than a certain percentage, for example, 10% from the system's expected task quantity, preventing massive data errors at the source.
Scenario 185. An unexpected raw material shortage threatens to halt a critical manufacturing line in 10 minutes. The only available stock is currently sitting in an offline quarantine storage zone, awaiting secondary lab clearance. How do you manage this high-priority emergency stock transfer under pressure?
Answer: this requires a quality release bypass combined with an ad hoc stock transfer. I would coordinate with the quality manager to post a temporary manual usage decision or status change in EWM to release the specific pallets from quality Q3 to unrestricted F2. I would then immediately use transaction /SCWM/add_prod on the RF to create an ad hoc warehouse task with the highest priority value 1. This bypasses the standard wave and staging queues, pushing the movement task directly to the screen of the nearest forklift operator, ensuring the material reaches the production supply area before the line halts. Pro tip: create an emergency WPT warehouse process type in advance. This WPT should be configured with immediate task confirmation and mapped to a dedicated emergency queue that preempts all other picking and put-away tasks, allowing you to execute critical line-side transfers in seconds.
Category 17 Conclusion.
Mastering exception handling is what separates a theoretical EWM consultant from a battle-tested expert. By configuring robust exception codes, automating dynamic inventory recounts, and managing late-stage order cancellations, you build a resilient warehouse that can absorb physical mistakes, mechanical failures, and sudden supply changes without halting operations.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 17 to Category 18.
Even if your physical exception handling is perfect, a digital system is only as good as its underlying performance. In large-scale, high-velocity distribution centers, a half-second delay in task confirmation can cascade into hours of truck congestion at the gate. We now transition from physical warehouse exceptions to the performance of the system itself. Performance and support. This is where we diagnose database bottlenecks, queue backlogs, RF timeouts, and large-scale transactional optimization. Let's explore Category 18.
Category 18. Performance and support scenarios.
System performance is critical for maintaining high warehouse velocity. This category covers the technical and analytical skills required to support high-volume EWM systems. You will face scenarios on SQL database locks, memory overflows on RF devices, slow warehouse monitor nodes, and large-scale data cleansing and stock correction strategies.
Category 18. Performance and support scenarios.
Here are the 8 critical scenarios covered in this category. Scenario 186. System slow during peak warehouse hours. Scenario 187. Mass WT creation delay. Scenario 188. Queue backlog issue. Scenario 189. RF transactions timing out. Scenario 190. Warehouse monitor performance issue. Scenario 191. Database lock during wave release. Scenario 192. Large-scale stock correction requirement. Scenario 193. High-volume e-commerce order optimization. Total 8 scenarios. Let's dive into Scenario 186.
Scenario 186. During the peak shipping window, the system experiences severe transaction response delays, slowing down picking and put away across the entire facility. How do you diagnose and resolve this peak hour performance lag?
Answer: diagnosing peak hour slowdowns requires a comprehensive trace of system resources and lock contention. First, I would run transaction SD03N workload monitor to analyze whether the bottleneck is database heavy, CPU bound, or network related. I would also check transaction DB02 to monitor database tablespace usage and database locks. In EWM, peak hour lag is often caused by concurrent heavy processes, such as scheduled wave release jobs running at the exact same time as a mass replenishment run. I would resolve this by separating these heavy background tasks into different time windows and optimizing index fields on frequently queried custom tables. Pro tip: check your system's RFC server group settings. If EWM and ERP are sharing the same limited dialog work processes during peak hours, configuring a dedicated RFC server group for EWM transaction queues, such as in transaction RZ12, will prevent core ERP users from starving EWM of critical processing threads.
Scenario 187. A planner attempts to release a wave containing 10,000 delivery items, but the system hangs on creating warehouse tasks, and the creation process takes over 45 minutes, stalling the shift. How do you troubleshoot and optimize this mass WT creation delay?
Answer: mass WT creation delays point to serial task bottlenecks or inefficient index paths. I would resolve the delay using the following steps. 1. Analyze process locks. Check transaction SM12 to see if database table locks on /scwm/ordem_o open warehouse tasks are blocking parallel task creation. 2. Implement parallel processing. Update the wave release and task creation parameters to use parallel processing in the background, utilizing multiple RFC work processes. 3. Check storage bin search indexing. Verify that the storage type search sequences SDSS are not looping through thousands of blocked or inactive bins, which creates massive database query loops. 4. Audit system logs SLG1. Run the application log with object/scwm/wave to identify if specific custom baddie code is causing a long-running execution loop for each task. Pro tip: in the parallel processing settings, set the block size to an optimized number, for example, 50 to 100 delivery items per block. If the block size is too large, the system is starved of memory. If too small, the system spends too much overhead context switching between different database threads.
Scenario 188. After a weekend maintenance window, the outbound QRFC queues SMQ1 are backed up with 15,000 unprocessed messages, causing stock confirmations to be severely delayed in ERP. How do you resolve this queue backlog?
Answer: clearing a massive queue backlog requires optimizing the QRFC scheduler parameters and running parallel restarts. I would execute the following steps. 1. Monitor the queue bottleneck. Check transaction SMQ1 to identify which queue names such as DLV or core stock updates are causing the primary blockade. 2. Activate queue scheduler SMQR. Ensure that the inbound and outbound schedulers are registered and running with maximum resource allocations. 3. Execute mass queue re-execution. Use the queue recovery or manual execution utility to select and force restart groups of queues in parallel. 4. Analyze failed messages sysfail. Find and isolate any queues with sysfail status to a separate queue group so they do not block the active, healthy queues behind them. Pro tip: do not attempt to run a massive backlog in a single, standard thread. Temporarily increase the max runtime and max connections in the SMQR scheduler settings. This allows the system to spawn up to 20 parallel work processes to clear the 15,000 backlogged messages in minutes instead of hours.
Scenario 189. Handheld RF terminal users are intermittently receiving transaction timeout or connection reset screens mid-scan, forcing them to restart their sessions and losing partial task data. How do you troubleshoot this RF timeout issue?
Answer: RF timeouts are usually caused by long-running database selects, weak network signals, or short web dispatcher session timeouts. I would troubleshoot the issue as follows. 1. Check ICF service settings. In transaction SICF, check the timeout settings for the warehouse's active ITS mobile service node, for example, the standard ITS mobile service path. 2. Analyze work process allocation. Verify that the system has enough dialog work processes available to handle the concurrent RF connections during peak shifts. 3. Check database lock tracing ST05. Run a SQL performance trace on the specific RF logical transaction, for example, picking to see if it is waiting for a database response. 4. Review network keep alive logs. Work with the network team to verify if the Wi-Fi access points are dropping the TCP/IP socket connection during idle periods. Pro tip: set the ITS mobile session timeout parameter to a reasonable limit such as 15 minutes, and ensure the web dispatcher has session persistence enabled. This prevents the system from dropping the picker's session during minor Wi-Fi handoffs between different physical access points.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 190. When a supervisor opens the physical stock node in the warehouse monitor /SCWM/mon to view inventory, the system runs for 5 minutes and then terminates with a time_out dump. How do you optimize the monitor's performance?
Answer: poor monitor performance is typically caused by unoptimized selection criteria or missing database index structures on stock tables. I would resolve the issue using the following steps. 1. Restrict selection criteria. Instruct the user to apply mandatory search filters such as a specific storage type or activity area rather than querying the entire warehouse. 2. Enable background processing. Configure the monitor node to run in the background, or use a save selection variant that pre-filters the data payload. 3. Run SQL trace ST05. Analyze which SQL select statements on the core EWM stock database tables, such as the main physical stock tables, are taking the longest time and causing the timeout. 4. Check database statistics update. Ensure that the database optimizer statistics for the core EWM tables are updated regularly using transaction DB13 to allow efficient search path planning. Pro tip: in the EWM warehouse monitor configuration, you can set a max number of hits limit, for example, 5,000 rows for heavy nodes like physical stock or warehouse tasks. This prevents the system from pulling millions of rows into the application layer, completely eliminating the risk of a time_out dump.
Scenario 191. When multiple waves are released simultaneously by background jobs, they clash on table locks, throwing database lock errors in the system log and causing some waves to fail to release. How do you resolve this concurrency lock issue?
Answer: concurrency locks during wave release occur when multiple processes attempt to write to the same delivery or stock tables simultaneously. I would resolve this as follows. 1. Audit table locks in SM12. Identify which tables, typically the wave header database tables, or open warehouse task tables like /SCWM/ordem_O, are experiencing the primary lock contention during the release. 2. Stagger background job scheduling. Adjust the background release schedule in transaction SM37 to stagger the waves, for example, releasing wave A at 1, wave B at 1:10 rather than launching all jobs at the exact same minute. 3. Verify block wave flag configuration. Ensure that the wave templates do not have the hard block flag active, which locks all deliveries in the wave even for non-conflicting tasks. 4. Check parallel processing resource group. Verify that the RFC server group used for the parallel release configured in transaction RZ12 has enough free work processes to handle the concurrent requests without queue stacking. Pro tip: use wave splitting based on activity area. By grouping your wave items so that wave A only contains tasks for aisle 1 to 5 and wave B only contains tasks for aisle 6 to 10, you ensure the tasks write to completely different database rows, eliminating concurrency locks.
Scenario 192. After a massive system migration, You discover that 50,000 inventory records have inconsistent stock type attributes between EWM and ERP, requiring a mass correction. Running individual posting changes is too slow. What is your strategy to execute this large-scale correction safely?
Answer: executing a mass stock correction of 50,000 records requires a phased, batch-based approach with automated tools to prevent database locking and queue overflows. I would first run the stock comparison tool transaction /scwm/ERP_stock check to export the complete delta between EWM and ERP to a spreadsheet, allowing me to group the inconsistencies by material and storage type. Instead of performing standard individual posting changes, I would develop a custom ABAP program utilizing standard EWM warehouse task creation APIs, for example, the /scwm/ to underscore create function module or class-based APIs to process the stock types in controlled batches of 1,000 records. I would schedule these updates to run in the background during a planned weekend maintenance window when the warehouse is completely inactive, ensuring that the system is fully locked for transactional users while the ledgers are aligned. Pro tip: deactivate your outbound QRFC queues SMQ1 for the duration of the mass update. Let EWM write the posting changes locally first, and then release the ERP update queues in blocks of 5,000 messages. This prevents the ERP system's inbound QRFC gateway from being completely overwhelmed and crashing during the synchronization.
Scenario 193. An e-commerce retailer experiences a 400% surge in order volume during a holiday sale. The warehouse is flooded with thousands of single-item and double-item orders, causing picker travel times to skyrocket. How do you optimize the system setup to handle this high-volume fulfillment?
Answer: optimizing high-volume e-commerce picking requires transitioning to a batch picking and sortation strategy in EWM. I would first adjust the wave templates to group these single-item and double-item orders by zone and activity area. I would then configure a dedicated WOCR that combines up to 50 of these small orders into a single, consolidated warehouse order. The picker is guided to pick the cumulative quantity in a single pass, for example, picking 50 units of the same item at once. The picked bulk HU is then routed to a packing put wall or sorting work center, where EWM's deconsolidation and packing transactions guide the operator to split the items into individual customer shipping boxes, drastically reducing travel time and maximizing throughput. Pro tip: leverage cartonization planning cap. By pre-calculating the correct box size for these high-volume orders during the wave release phase, you can print the final shipping label times before times picking. The picker can then pick directly into the final shipping carton on their trolley, completely bypassing the downstream packing and sortation step for single-item orders.
Category 18 Conclusion.
Optimizing system performance and support is critical for maintaining high warehouse velocity. By mastering RFC server group configurations, parallel task creation blocks, and database lock resolution during wave release, you ensure EWM performs optimally during peak shifts. This robust support structure prevents database-level bottlenecks from translating into physical queue delays.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 18 to Category 19.
While maintaining a high-performance system is crucial for daily operations, the most challenging phase of any warehouse's lifecycle is the transition itself. As organizations sunset legacy SAP ERP systems, migrating from classic warehouse management WM to S/4HANA EWM is one of the most high-stakes projects a consultant can execute. We now transition from performance support to system transformation, migration, and S/4HANA scenarios. This is where we handle legacy conversions, cutover strategies, and parallel operations. Let's explore Category 19.
Category 19. Migration and S/4HANA scenarios.
The transition from legacy SAP WM to S/4HANA EWM is a strategic milestone for any digital supply chain. This category covers the architectural and technical aspects of system migration. You will face scenarios on data extraction, open transaction cutovers, bin redesigns, and managing the unique performance demands of embedded EWM.
Category 19. Migration and S/4HANA scenarios.
Here are the 7 critical scenarios covered in this category. Scenario 194, WM to EWM migration approach. Scenario 195, open transfer orders during migration. Scenario 196, legacy bin structure redesign. Scenario 197, embedded EWM performance concerns. Scenario 198, brownfield migration issue handling. Scenario 199, cutover weekend warehouse strategy. Scenario 200, parallel warehouse operation during migration. Total 7 scenarios. Let's dive into Scenario 194.
Scenario 194. A global manufacturing company is planning to migrate their legacy ERP system to S/4HANA. The CIO asks you to propose the optimal WMS migration strategy from classic LEWM to EWM, evaluating greenfield versus brownfield versus selective data transition. How do you design this migration architecture?
Answer: designing a WM to EWM migration requires a structured architectural evaluation based on business goals, process debt, and technical readiness. For a company with heavily customized legacy processes and outdated structures, I would strongly recommend a greenfield new implementation approach. This allows the organization to completely redesign their physical layout and adopt standard S/4HANA EWM processes, eliminating decades of custom technical debt. However, if the business has highly optimized, stable physical processes and wants to keep their current setup intact, a selective data transition or a brownfield conversion is appropriate. This leverages standard SAP data migration tools such as the Migration Cockpit via Transaction LTMC to convert master data, storage bins, and physical inventory, while minimizing project scope and business disruption. Pro tip: never do a straight, one-to-one lift and shift of classic WM customization to EWM. EWM's architecture specifically around storage control, packaging specifications, and activity areas is fundamentally different. A direct technical conversion will result in an over-engineered, slow-performing system that underutilizes EWM's advanced automation and optimization features.
Scenario 195. During the final prep for a warehouse cutover, you discover that the legacy SAP WM system still has 500 unconfirmed transfer orders TOs and open deliveries, blocking the data extraction. How do you resolve these open transactions?
Answer: handling open transactions during a migration cutover requires a strict freeze and systematic closure. I would execute the process as follows. 1. Enforce transaction freeze. Implement a hard administrative lock on the legacy ERP system to prevent any new transfer orders or deliveries from being created. 2. Run Open Task Audit. Execute standard WM reports such as Transaction LT22 or LCOV to identify all pending, unconfirmed transfer orders across all storage types. 3. Enforce physical and logical closure. Force the warehouse team to physically complete and system confirm all active picking or put-away tasks. 4. Cancel remaining open TOs. For any remaining tasks that cannot be physically completed, manually cancel the open TOs and return the delivery items to unpicked status so they can be replanned post-migration. Pro tip: transactional data cannot be migrated one-to-one from LEWM to EWM. All open transfer orders and warehouse documents must be completely closed or canceled in the legacy system before the stock snapshot can be extracted and uploaded to the new EWM warehouse.
Scenario 196. Your client is migrating to S/4HANA EWM, and they want to redesign their legacy WM3 coordinate bin naming structure to support EWM's dynamic sorting, travel path optimization, and narrow aisle picking. How do you architect this bin redesign?
Answer: architecting an EWM storage bin redesign requires shifting from static naming conventions to dynamic, sort-friendly structures. I would design the new bin structure to use an alphanumeric format that reflects the physical coordinate system, for example, aisle stack level, such as aisle 01, stack 04, level 02. In EWM, we must define the bin access type and link each bin to a specific activity area. During the migration phase, I would utilize the S/4HANA migration cockpit with standard storage bin migration objects. This allows us to map the old WM bins to the new EWM structure via staging tables or XML templates, ensuring that the final bin sorting transaction /SCWM/SBSD optimizes the travel path of resources on day 1. Pro tip: do not create EWM bins without mapping them to activity areas. If bins are not assigned to sorted activity areas, the system will fail to group picking tasks logically in the WOCR, and your pickers will face highly inefficient, unsorted travel paths across the warehouse.
Scenario 197. Your client is deploying S/4HANA embedded EWM, and the basis team is concerned that high-frequency RF picking transactions will consume too much CPU and memory, impacting the core ERP financial postings. How do you address these performance concerns?
Answer: mitigating embedded EWM performance risks requires strict database and resource isolation. I would execute the following strategies. 1. Activate RFC server groups. Configure dedicated RFC server groups in transaction RZ12 to isolate EWM transactional queues, preventing them from consuming core ERP dialog processes. 2. Disable real-time queue updates. Use asynchronous delivery updates instead of synchronous updates where possible, allowing ERP postings to queue during peak hours. 3. Optimize RF screen payload. Configure the active ITS mobile service nodes in transaction SICF to transmit only the minimum required screen metadata, reducing network latency. 4. Perform database indexing. Regularly run database maintenance and update statistics via transaction DB13 for EWM-specific tables like /SCWM/ordem_O to ensure fast search paths. Pro tip: for extremely high-volume warehouses with intensive automation, MFS integration, or strict workload isolation requirements, evaluate decentralized EWM alongside embedded EWM as part of the architecture assessment.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 198. During a brownfield conversion to S/4HANA, the standard migration tool fails during the warehouse product master conversion step, throwing an error and halting the project. How do you troubleshoot and resolve this brownfield failure?
Answer: brownfield conversion failures usually stem from inconsistent material master configurations or custom field mapping conflicts. I would resolve the issue using the following steps. 1. Analyze the conversion log. Review the detailed error logs in the S/4HANA Migration Cockpit Transaction (LTMC) or the Migrate Your Data app to identify the specific material number causing the fail. 2. Check material base unit of measure UOM. Ensure that the materials base UOM has not been changed or set inconsistently in the ERP tables. Inconsistent UOMs will block EWM master data creation. 3. Validate mapping of LEWM to EWM. Ensure the global mapping tables for LEWM warehouse number to EWM warehouse number are fully configured and consistent. 4. Exclude custom append fields. If custom fields were added to the MARC or MARA tables, verify if they have been correctly mapped in the LTMOM migration object modeler to prevent database insert errors. Pro tip: for a brownfield conversion, always run a pre-migration validation report in the legacy system. This checks for inconsistent master data, inactive materials, and open queues before the conversion starts, catching 90% of the data errors that cause migration cockpit crashes.
Scenario 199. You are designing the 48-hour cutover weekend strategy for a massive retail warehouse transitioning to S/4HANA EWM. You must freeze physical operations, perform the final inventory data upload, and test the system before Monday morning. How do you design this cutover roadmap?
Answer: a successful 48-hour cutover requires a highly structured, hour-by-hour cutover runbook that synchronizes physical warehouse steps with system-level milestones. The strategy begins on Friday evening with a complete physical and logical freeze of the warehouse. All open shipments are posted, and any open transactional queues are fully processed and cleared. Once the legacy systems are confirmed to have 0 open items, we extract the final physical stock snapshot from the legacy system. On Saturday, we use standard migration tools such as the standard EWM stock migration report to upload the inventory into EWM. Sunday is reserved for smoke testing. We perform dummy check-ins, unloads, pewterways, picks, and shipping confirmations on the RF devices to verify connection stability and printer routing, ensuring the warehouse is fully ready for live production on Monday morning. Pro tip: always include a rollback plan with a specific go-no-go decision timestamp on your cutover checklist, usually by Sunday noon. If critical system bugs or master data corruption are discovered during Sunday morning smoke testing, having a pre-planned rollback strategy prevents a catastrophic warehouse shutdown on Monday.
Scenario 200. A multinational corporation is rolling out S/4HANA EWM site by site over 18 months. During this transition, Site A will run on the new EWM platform, while Site B remains on the legacy ERP WM system, and both must communicate with the same ERP instance. How do you configure and govern this parallel operation?
Answer: governing parallel warehouse operations requires a robust multi-warehouse ERP integration architecture that isolates different storage locations under the same plant. I would configure this by defining two distinct storage locations in ERP under the same plant ID, assigning SLOC001 to the legacy LEWM warehouse number and SLOC002 to the new S/4HANA EWM warehouse number. In the integration settings, ERP will be configured to trigger standard outbound deliveries. If the delivery points to SLOC001, the system will route the transaction via standard LEWM protocols, and if it points to SLOC002, S/4HANA will route it via QRFCs or advanced shipping and receiving to EWM. This ensures that master data remains shared, but transactional execution is completely isolated by storage location. Pro tip: pay close attention to intercompany stock transfers between the legacy site and the new site. Treat these as standard stock transport orders STOs with dual-step postings. This ensures that EWM and LEWM can cleanly post goods issue and goods receipt without requiring complex cross-system transactional queue handshakes.
Category 19 Conclusion.
Mastering migration and S/4HANA transformation is what differentiates a standard EWM consultant from an enterprise architect. By implementing structured WM to EWM migration strategies, executing precise cutover runbooks, and ensuring seamless multi-warehouse coexistence, you minimize business disruptions and pave the way for modern, intelligent warehousing.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 19 to Category 20.
Once the migration is complete and your system is running on S/4HANA, the true test of your EWM design begins. Every industry has unique business models, and every client has specific operational demands that standard configurations cannot always meet. We now transition from system migration to customized business solutions. Client requirement scenarios. This is where we solve unique, high-value client needs. From multi-client 3PL isolation and cold chain pharma handling to manufacturing PP integration and seasonal demand surges. Let's explore Category 20.
Category 20. Client Requirement Scenarios.
Client requirement scenarios test your ability to translate complex, industry-specific business processes into stable, standard SAP EWM designs. This category covers highly tailored configurations, including 3PL multi-tenant stock isolation, time-critical pharma cold chains, and direct integration with manufacturing production lines. Mastering these scenarios ensures you can deliver tailored business value without over-customizing the system.
Category 20. Client Requirement Scenarios.
Here are the 9 critical scenarios covered in this category. Scenario 201, Same-Day Delivery Processing Requirement. Scenario 202, 24/7 Warehouse with Zero Downtime Requirement. Scenario 203, Multi-Client Warehouse Management. Scenario 204, Seasonal Demand Spike Handling. Scenario 205, Customer-Specific Labeling Process. Scenario 206, Regulatory Compliance Storage Requirement. Scenario 207, Pharma Cold Chain Warehouse Requirement. Scenario 208, E-Commerce High Volume Small Order Picking. Scenario 209, Manufacturing Supply to Production Integration. Total 9 scenarios. Let's dive into Scenario 201.
Scenario 201. An e-commerce client has a strict same-day delivery promise for orders placed before 2 p.m., meaning they must be picked, packed, and loaded onto the carrier vehicle within 60 minutes of order creation. How do you design the EWM process flow to guarantee this velocity?
Answer: achieving same-day delivery speed requires an automated, bypass-driven EWM architecture. First, I would configure a dedicated same-day wave template with a strict 30-minute release cycle and high-priority processing. I would use the condition technique to automatically assign deliveries to this wave based on the ERP sales order priority. During the wave run, EWM immediately generates high-priority warehouse tasks priority 1 that are pushed directly to the RF terminals of dedicated fast fulfillment teams. Furthermore, I would leverage cartonization planning cap to pre-calculate box sizes during wave release so that pickers pick directly into shipping boxes, completely bypassing the downstream packing station and sending the completed handling unit straight to the staging lane for immediate vehicle loading. Pro tip: avoid standard manual release processes for same-day waves. Configure automatic wave release linked to the wave's cutoff time. This ensures that even if a supervisor is busy, the wave will release automatically in the background, keeping the fulfillment line in continuous, predictable motion.
Scenario 202. A large-scale distribution center operates 24/7 with zero tolerance for system downtime. The IT team needs to perform system upgrades and maintenance patches without interrupting RF picking, packing, or shipping operations on the floor. How do you architect a zero-downtime EWM solution?
Answer: for warehouses with strict availability requirements, evaluate both embedded and decentralized EWM architectures. Decentralized EWM can provide stronger workload isolation and maintenance flexibility, while embedded EWM may still meet availability targets when properly sized and architected. If a decentralized deployment is chosen, it decouples the physical warehouse operations from the core ERP system. During a planned ERP maintenance window, the decentralized EWM system remains fully operational. RF users continue picking, packing, and loading trucks locally. EWM buffers all transactional updates such as goods issues and goods receipts in outbound RFC queues SMQ1 and SMQ2. Once the ERP system is brought back online, the queues automatically synchronize the backlog, ensuring zero disruption to the physical logistics flow. Pro tip: for database-level upgrades on the EWM system itself, implement an active-passive clustering model or utilize SAP's near-zero downtime NZDT service. This allows database replication to run in the background, minimizing the final switchover window to under 10 minutes, which can be easily absorbed during a shift change.
Scenario 203. A third-party logistics provider 3PL manages stock for 5 different retail clients in a single, shared warehouse, and they must guarantee that different clients' stock is logically isolated and cannot be picked or viewed by unauthorized users. How do you configure this multi-client warehouse in EWM?
Answer: configuring a 3PL multi-client warehouse requires strict master data and organizational isolation. I would implement the isolation using the following configurations. 1. Map entitled to dispose. Define an ownership and entitlement structure that uniquely identifies each client. using organizational elements such as plants or custodians appropriate to the ERP and EWM design, and replicate these as entitled to dispose in EWM. 2. Define owner business partners. Create unique business partners to represent the owner of the stock for each client, ensuring every physical handling unit is tagged with the correct owner ID. 3. Configure stock segregation. Set up EWM stock types, for example, F1 versus F2 to include the owner and entitled to dispose attributes, physically isolating the stock on the shelves via bin search rules. 4. Apply RF user authorization profiles. Use standard SAP authorization objects such as /SCWM/RSRC and /SCWM/2 to restrict RF users to only see and confirm tasks for their assigned client's queue. Pro tip: leverage shared storage types with addition to existing stock restriction. This allows the 3PL to use the same physical racking for multiple clients to maximize space, while EWM strict owner and entitled rules prevent different client stock from ever being mixed in the same physical storage bin.
Scenario 204. A retail warehouse experiences a 500% surge in order volume during the winter holiday season. Bins for popular products are constantly emptying, and forklift travel times are soaring because fast-moving items are stored deep in the warehouse. How do you handle the seasonal demand spike?
Answer: managing seasonal demand spikes requires a proactive dynamic slotting and forward staging strategy. I would run the EWM slotting utility transaction /SCWM/slot to analyze historical consumption and upcoming sales forecasts. Based on the results, the system will automatically reclassify seasonal fast movers and generate reorganization, warehouse tasks to move these high-demand items from distant reserve zones to the nearest pick face bins at ground level. I would also adjust the WOCR to implement zone picking and batch picking to reduce picker travel time, and increase the fixed bin replenishment thresholds minimum or maximum quantities to ensure the pick faces are aggressively stocked ahead of the morning peak. Pro tip: set up a temporary forward staging storage type near the shipping dock specifically for the top 10 seasonal SKUs. By routing inbound receipts of these fast movers directly to this staging area, you can fulfill 80% of your peak season orders directly from the dock, completely bypassing the main racking system.
Scenario 205. A major retailer requires that all deliveries shipped to their stores include a custom shipping label containing specific barcode layouts and store delivery instructions, which differs from your standard labeling. How do you configure this customer-specific labeling?
Answer: I would configure this using the condition technique inside the post-processing framework PPF. I would execute the following setup steps. 1. Create custom SmartForm layout. Develop the custom shipping label SmartForm or Adobe form according to the retailer's exact specifications. 2. Configure PPF action profile. Create a specific PPF action, for example, /SCWM/print_label_cust in the outbound delivery profile. 3. Define condition table key fields. Set up an access sequence in the condition technique that includes the sold to party or customer group as a key field. 4. Maintain condition records. Maintain the corresponding condition records for the retailer, for example, in transaction /SCWM/DLV_PPF_conf to map the business partner ID to the custom PPF print action, ensuring only their orders trigger this specific layout. Pro tip: integrate this with the Value Added Services VAS module. If the label requires physical inspection or manual application at a packing bench, EWM can generate a VAS order that guides the packing operator to print, verify, and apply the custom label before shipping.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 206. A distribution center stores food-grade ingredients and industrial pesticides. Regulatory bodies demand strict segregation to prevent cross-contamination, backed by verifiable audit trails. How do you configure EWM to guarantee compliance?
Answer: enforcing regulatory compliance requires implementing hard segregation checks within EWM's put-away logic. I would configure the system as follows. 1. Define storage sections. Create distinct storage sections for food and chemicals within the warehouse storage types. 2. Configure storage section check. Activate the storage section check in the storage type definition to make segregation a hard, system-enforced rule. 3. Maintain storage section indicators. Assign a storage section indicator to each product in their warehouse product master, for example, food for ingredients, pest for pesticides. 4. Set up search sequences. Map the search sequences so that food products are only permitted to find bins in the food section, and throw an immediate error if a user attempts a manual override. Pro tip: activate EWM's audit trail, or change logs for the warehouse product master and storage bin configurations. This ensures that any manual changes to material classifications or bin assignments are fully recorded with a user ID and timestamp, providing a clean audit trail for regulatory inspectors.
Scenario 207. A pharmaceutical distributor handles temperature-sensitive vaccines that must remain between 2 and 8 degrees Celsius. The system must track the cold chain status and ensure that any exposure to ambient temperatures during receiving or staging is strictly limited and audited. How do you configure this cold chain process?
Answer: managing cold chains requires integrating process-oriented storage control (POSC) with temperature logging and time-critical execution. I would configure EWM as follows. 1. Implement multi-step POSC. Configure an inbound POSC process with steps for unloading unli temperature verification temp and final put-away PTWY. 2. Define intermediate cold staging zone. Route the pallets from the truck directly to an intermediate temperature monitored staging zone instead of the open dock. 3. Time-critical put-away tasks. Configure a time limit for the put-away tasks. If the task to move the vaccine to the main freezer is not confirmed within 30 minutes of unloading, the system triggers an escalation alert. 4. Track temperature class. Maintain the temperature class in the warehouse product master to ensure the system automatically determines the correct cold storage type. Pro tip: integrate EWM with IoT temperature sensors or Bluetooth data loggers. When the vaccine HU is scanned on the RF at check-in, EWM can capture the temperature log data via an API and automatically attach it to the HU record, providing immediate digital proof of cold chain integrity.
Scenario 208. An e-commerce distributor experiences massive spikes in small orders, 1 or 2 items per order. Pickers are spending too much time traveling, and packing stations are congested. How do you configure EWM to optimize this high-volume fulfillment?
Answer: Optimizing small order e-commerce picking requires transitioning from single order picking to a batch and sort process. I would implement this using 1. Wave template grouping. Configure a wave template to group thousands of small orders by physical aisle and activity area to minimize picker travel. 2. Consolidated WOCR batch picking. Create a warehouse order creation rule that combines up to 50 individual delivery items into a single, consolidated picking warehouse order. 3. Implement pick to cart on RF. Configure the RF picking transaction to guide the picker to collect the total bulk quantity of an item. For example, pick 20 units of item in one pass. 4. Route to put wall sortation work center. Route the bulk picked HUs to a put wall work center where EWM's deconsolidation transaction guides the operator to sort the items into individual customer shipping boxes. Pro tip: leverage cartonization planning cap. By pre-calculating the correct box size for these small orders during the wave release phase, you can print the shipping labels in advance. The picker can then pick directly into the final shipping carton on their trolley, completely bypassing the downstream packing and sortation step.
Scenario 209. A manufacturing plant needs a just-in-time replenishment process to feed raw materials to their assembly lines. The production system PP is separate from EWM, and consumption must be posted accurately as soon as parts are used. How do you configure this production integration?
Answer: managing manufacturing replenishment requires advanced production integration utilizing the production material request PMR. I would implement the integration using the following steps. 1. Generate production material request. Set S/4HANA PP to automatically replicate the production order to EWM as a PMR upon order release. 2. Define production supply areas PSA. Set up PSAs in EWM and map them to physical staging storage bins located next to the assembly line. 3. Configure staging methods. Define staging methods in EWM such as crate parts for bulk materials and release order parts for specific production order requirements. 4. Post-production consumption. Configure the system to automatically trigger consumption posting goods issue in EWM and ERP when the production execution system confirms assembly completion backflush. Pro tip: use clear PSA functionality in the warehouse monitor. This utility allows you to find any unused raw materials left over at the PSA after a production run is complete and automatically generates return tasks to move them back to the main reserve racking, keeping the production floor clean and inventory accurate.
Category 20 Conclusion.
Mastering tailored client requirements is what transforms a standard functional consultant into a true business solutions architect. By implementing modular designs for multi-client 3PL setups, seasonal demand slotting, and secure pharma cold chain procedures, you ensure EWM delivers maximum operational value without succumbing to fragile, over-customized code.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 20 to Category 21.
Even the most elegantly designed client configurations will eventually encounter system-level bugs, unexpected locks, and transactional errors in production support. When a high-volume warehouse is running and a critical task fails to create or an RF device dumps mid-transaction, you cannot afford to guess. We now transition from custom business designs to the ultimate diagnostic toolkit, debugging and troubleshooting. This is where we learn how to trace code, analyze database dumps, and resolve complex system blocks under pressure. Let's explore Category 21.
Category 21. Debugging and troubleshooting scenarios.
Debugging and troubleshooting is the ultimate test of an EWM consultant's technical depth. This category covers systematic diagnostic paths for core execution failures, including stuck queues, missing warehouse tasks, silent PPF failures, and unexpected RF transaction dumps. Mastering these debugging scenarios ensures you can quickly isolate root causes, protect data integrity, and restore active warehouse throughput.
Category 21. Debugging and troubleshooting scenarios.
Here are the 10 critical scenarios covered in this category. Scenario 210, WT not created troubleshooting. Scenario 211, Q stuck troubleshooting. Scenario 212, PPF action not triggered debugging. Scenario 213, bin determination failing unexpectedly. Scenario 214, WOCR not working after transport movement. Scenario 215, RF transaction dumps intermittently. Scenario 216, EWM monitor showing inconsistent stock. Scenario 217, repeated QRFC errors. Scenario 218, delivery document locked by another process. Scenario 219, unexpected stock type determination issue. Total 10 scenarios. Let's dive into Scenario 210.
Scenario 210. A wave is released, but no picking warehouse tasks are generated, and the system fails to display any obvious error messages in the monitor. What is your systematic troubleshooting path to diagnose this issue?
Answer: this indicates a silent task creation failure. I would troubleshoot the system using the following steps. 1. Check wave status and logs. Access transaction/scwm/wave and check if the wave status is released with errors or if it contains unreleased items due to zero stock. 2. Analyze wave release log. Run transaction SLG1 with object/scwm/wave to check for any detailed execution errors or custom baddie failures. 3. Verify stock assignment. Use the warehouse monitor to confirm if the stock is logically available in the active pick face storage types or if it is currently locked by a pending inventory count. 4. Verify search sequence configuration. Check the outbound storage type search sequence to ensure a valid source path exists for the specific product and warehouse process type. Pro tip: check for incomplete deliveries. If the outbound delivery has an inactive status or is missing validation checks, the wave release engine will skip task creation entirely without throwing an error in the picking monitor.
Scenario 211. An outbound delivery confirmation fails to update ERP because the transaction queue is stuck in SMQ2 with a technical error. How do you systematically troubleshoot and resolve this stuck integration queue?
Answer: resolving a stuck integration queue requires checking the system log and connection parameters. I would execute the troubleshooting as follows. 1. Read the queue status message. Double-click the queue status in transaction SMQ2 to display the exact technical error message returned by the system. 2. Check application log SLG1. Open transaction SLG1 in the target system and search for logs under the delivery object to identify the functional root cause of the block. 3. Isolate and test the RFC connection. Test the transactional RFC connections in transaction SM59 to verify that the communication handshake is fully functional. 4. Reprocess or divert the queue. If the error was temporary, such as a system lock, manually re-execute the queue. If it is a hard data error, temporarily stop or isolate the queue to prevent subsequent business transactions from being blocked. Pro tip: do not delete a stuck queue in production unless you are prepared to manually reconcile the stock difference. Deleting a queue deletes the transaction permanently, leaving EWM and ERP in an inconsistent state that must be corrected via manual inventory postings.
Scenario 212. A user confirms an outbound packing task, but the shipping labels fail to print, and the post-processing framework PPF monitor shows that the print action was not even scheduled. How do you debug this silent PPF failure?
Answer: debugging a missing PPF action requires verifying both the master data and the scheduling logic. I would execute the process as follows. 1. Verify PPF action profile assignment. Confirm that the correct action profile is mapped to the active document type and is visible on the delivery header. 2. Analyze schedule conditions. Open transaction SBPFP and check if the schedule condition evaluated to false, preventing the action from being scheduled. 3. Check condition records. Verify in transaction/SCWM/DLV_PPF_conf or the corresponding PPF condition records transaction that a valid condition record exists for your warehouse, document, and partner attributes. 4. Run PPF application log SLG1. Analyze the application log using subobject/SCWM/PPF to check if the determination engine crashed during execution. Pro tip: use the trace feature in the PPF scheduling class. By setting a breakpoint in the schedule condition method such as evaluate_conditions, you can step through the logic to see exactly which variable such as carrier or shipping point failed to match.
Scenario 213. During put-away task creation, EWM consistently fails to find a destination bin for a product, even though several empty bins are physically visible in the aisle. How do you troubleshoot this bin determination failure?
Answer: this is caused by a mismatch between physical parameters and EWM search logic. I would troubleshoot the failure using these steps. 1. Verify put-away control indicator PSCI. Check the warehouse product master to ensure the product has the correct PSCI assigned and that it is mapped to an active storage type search sequence. 2. Check bin capacity and dimension limits. Verify if the bin capacity check is active and if the product's physical dimensions, weight, and volume exceed the remaining capacity of the empty bins. 3. Check storage type strategy settings. Review the put-away strategy in the storage type configuration such as empty bin or addition to stock to confirm if the system selection rules are filtering out the active racking. 4. Audit bin locking status. Use transaction/SCWM/MON to verify if the empty bins are blocked for put-away due to a pending physical inventory or a manual block. Pro tip: use the detailed determination log when creating a task manually in transaction/SCWM/TODLV. The log lists every single storage type and bin searched by EWM, providing the exact reason, for example, bin type mismatch, why each option was rejected.
Scenario 214. After importing a configuration transport into the QA system, the warehouse order creation rules WOCR stop grouping tasks correctly, defaulting all tasks to the standard rule. How do you troubleshoot and resolve this WOCR failure?
Answer: this issue usually points to outdated system buffers or unsorted activity areas. I would resolve the problem as follows. 1. Verify search sequence customizing. Check the WOCR search sequence table to confirm that the imported rules are active and mapped to the correct activity area and activity. 2. Execute table buffer synchronization. Run the buffer synchronization command /$sync in the command field to clear and rebuild the system's table buffers. 3. Validate activity area sorting. Verify that the activity area sorting and sequence definitions remain intact after transport import using transaction/SCWM/SBSD if resorting is required. 4. Check WOCR filters and limits. Verify that the filters and limits assigned to the WOCR in the target system were not corrupted or overwritten during the import. Pro tip: when importing WOCR changes, Table buffers specifically on configuration tables like /scwm/tcocr may not refresh instantly across all application servers. Running $$sync forces a complete refresh of the shared table buffers, resolving immediate post-transport anomalies.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 215. RF users report that the system intermittently crashes with a short dump mid-picking, forcing them to log out and log back in. How do you troubleshoot and debug this intermittent RF failure?
Answer: this requires tracing the runtime session and isolating custom enhancements. I would troubleshoot the issue as follows. 1. Analyze ABAP runtime errors SD22. Check transaction SD22 for short dumps occurring at the timestamp of the RF crashes to identify the specific program and exception. 2. Trace ITS mobile runtime sessions. Review ITS mobile and web dispatcher diagnostic logs to see if session timeouts are causing the dumps. 3. Isolate custom baddie enhancements. Check if custom enhancements such as RF screen exit baddies are attempting to process null fields or out-of-sequence inputs, triggering a runtime exception. 4. Review RF screen personalization. Verify if the user's personalization profile is calling a screen layout that contains fields not supported by the physical RF device resolution. Pro tip: many intermittent RF dumps are caused by users double-clicking or pressing enter too quickly, which sends overlapping HTTP requests to the web dispatcher, triggering a session synchronization dump.
Scenario 216. The warehouse monitor shows a different available stock quantity in the physical stock node compared to the stock by bin node, causing confusion for supervisors. How do you resolve this stock inconsistency?
Answer: stock inconsistencies are typically resolved by checking open reservations or running the check monitor. I would execute the troubleshooting as follows. 1. Verify open task allocations. Check if there are active, unconfirmed warehouse tasks that are reserving the stock, which would affect available stock but not physical stock. 2. Check stock consistency utilities. Run the standard EWM stock consistency check utilities such as transaction/scwm/check_stock_ERP or cross-system comparison reports to compare EWM inventory tables with ERP. 3. Analyze difference analyzer logs. Verify if some stock is logically sitting in the virtual 999 difference zone, which would exclude it from standard pickable stock. 4. Execute table consistency diagnostics. Run the check monitor log utility to search for database inconsistencies in the EWM stock tables. Pro tip: Stock inconsistencies in the monitor are often logical reservation issues rather than database corruption. Check if the stock is assigned to an active quality or inspection document, which automatically flags the stock as unavailable for standard warehousing tasks.
Scenario 217. Outbound transactional updates from EWM are failing repeatedly with a QRFC error in SMQ1, blocking all delivery confirmations. How do you troubleshoot and recover from repeated QRFC errors?
Answer: this requires resetting the scheduler and checking the target system ledger. I would troubleshoot the issue as follows. 1. Analyze SMQ1 details. Access transaction SMQ1 in EWM, double-click the failed queue, and read the explicit error description. 2. Check for closed posting periods. Verify in transaction MMPV if the current posting period is open in ERP. A closed period is a primary cause of repeated RFC failures. 3. Validate RFC connection ports. Test the RFC destinations and the transactional RFC ports TRFC in transaction SM59 to ensure the network path is fully functional. 4. Activate QRFC scheduler SMQR. Ensure that the queue scheduler is registered and running with maximum resource allocations to prevent queue stacking. Pro tip: set up an automatic queue restart schedule. You can configure the QRFC scheduler transaction SMQR with an automatic retry interval. This ensures that temporary network glitches or locking issues are resolved by the system without manual intervention.
Scenario 218. A picker is blocked from confirming their task because EWM throws an error stating that the outbound delivery document is locked by another process. How do you identify and resolve this locking block?
Answer: resolving document locks requires identifying the active session and releasing the lock safely. I would execute the process as follows. 1. Analyze lock entries in SM12. Run transaction SM12 in EWM and ERP to search for active locks on the delivery document tables such as /SCWM/DLV_HDR or /SCWM/DLV_item. 2. Identify the locking user or job. Check the user and transaction columns in SM12 to identify if a manual user or a background wave release job is holding the lock. 3. Review queue status in SMQ2. Check transaction SMQ2 to see if a lagging inbound queue is currently updating the delivery, which automatically locks the document during the update. 4. Perform manual lock deletion. If the locking user is inactive, for example, they left their PC with the transaction open, after confirming the originating process is no longer active, manually delete the lock entry in SM12 to unblock the picking process. Pro tip: avoid long-running manual delivery updates during peak picking shifts. Instruct master data and planning teams to avoid manual edits in transaction/SCWM/PRDO during wave execution, as manual locks will block RF confirmations instantly.
Scenario 219. During receiving, EWM is unexpectedly assigning a quality stock type Q4 to a product that should go straight to unrestricted F4, causing put-away delays. How do you resolve this stock type determination issue?
Answer: this is caused by an incorrect alignment between availability groups and stock types. I would correct the configuration using the following steps. 1. Check availability group mapping. Verify that the ERP storage location is mapped to the correct EWM availability group, for example, Group 001 for unrestricted in the system mapping tables. 2. Verify warehouse process type WPT. Check the WPT configuration to confirm that the stock type or availability group is not being overridden during the receiving activity. 3. Check product master settings. Verify if the stock type or availability group is maintained in the warehouse product master, as product-level settings override global mapping defaults. 4. Verify quality inspection rules. Ensure that no active quality inspection rules QIE are triggering an automatic quality hold for the product or the vendor. Pro tip: stock type determination is deeply tied to the availability group. If EWM is assigning Q4 instead of F4, it usually means the inbound storage location in ERP is mapped to availability group 002 quality instead of 001 unrestricted.
Category 21 Conclusion.
Mastering system debugging and transaction troubleshooting is the ultimate shield for production support. By implementing precise diagnostic paths for missing tasks, trace logging silent PPF failures, and analyzing ABAP database dumps, you ensure that transactional blocks are isolated and resolved in minutes, preventing database-level lock contentions from shutting down the physical warehouse floor.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 21 to Category 22.
While debugging and resolving system bottlenecks keeps your core warehouse running, a distribution center cannot thrive on standard storage alone. In modern manufacturing hubs, the warehouse is directly coupled with the assembly floor. We now transition from diagnostics and support to the direct integration of your warehouse with manufacturing execution. Production integration. This is where EWM steps up to supply raw materials and receive finished goods from assembly lines under S/4HANA Advanced Production Integration. Let's explore Category 22.
Category 22. Production Integration Scenarios EWM-PP and MES.
Production integration EWM-PP and MES is the programmatic bridge between material staging and manufacturing. This category covers advanced production integration using the Production Material Request (PMR), component staging to the Production Supply Area (PSA), consumption backflushing, and finished goods receipt. Mastering these scenarios ensures that raw materials flow just in time to the assembly line and inventory is posted accurately without communication lag.
Category 22. Production Integration Scenarios.
Here are the 8 critical scenarios covered in this category. Scenario 220. Production Material Request (PMR) not created in EWM after order release. Scenario 221. Staging to Production Supply Area (PSA) failing due to bin capacity. Scenario 222. Components physically consumed but EWM stock not updated. Scenario 223. Reversal of production consumption returned to PSA or warehouse. Scenario 224. Receipt from production with automatic HU creation missing. Scenario 225. Kanban empty signal not triggering EWM replenishment task. Scenario 226. Clear PSA process handling for unused components. Scenario 227. Co-product and byproduct receipt handling in EWM. Total 8 scenarios. Let's dive into Scenario 220.
Scenario 220. A production order is released and saved in S/4HANA, but the corresponding production material request (PMR) is missing in EWM, preventing any component staging. How do you troubleshoot and resolve this integration failure?
Answer: this is typically an integration failure at the document replication layer. I would troubleshoot and resolve the issue using the following steps. 1. Verify document type mapping. Check if the ERP production order type is correctly mapped to the EWM-PMR document type PWR in the configuration. 2. Inspect inbound queues SMQ2. Check the inbound RFC queues in EWM for stuck messages containing production order details. 3. Validate control cycle settings. Ensure that the control cycle in ERP transaction CO02 is configured with staging indicator 5 EWM staging. 4. Check distribution model. Verify the active production integration distribution model, for example, transaction/019 where applicable. Pro tip: use transaction/SCWM/PMR to check if the PMR exists, but is in inactive status due to a validation error, which prevents it from showing in the main staging monitors.
Scenario 221. The staging warehouse task for a critical production run fails to create because the designated production supply area PSA bin is full or lacks physical capacity. How do you resolve this staging bottleneck?
Answer: this is caused by a capacity mismatch at the line side staging area. I would resolve the bottleneck using the following steps. 1. Verify PSA bin assignment. Verify the PSA master data and storage bin assignment, for example, in transaction/SCWM/PSA. 2. Check bin capacity check method. Verify if the capacity check is active for the PSA storage type, and check the bin's maximum weight or volume configuration. 3. Allow multiple products. Ensure that the PSA storage type configuration allows mixed storage of multiple products to prevent system blocks on shared bins. 4. Adjust control cycle quantities. Reduce the replenishment quantity in the ERP control cycle to match the bin's physical limits. Pro tip: for high-frequency assembly lines, use cross-order staging transaction/SCWM/stage. This groups requirements across multiple active production orders, optimizing the replenishment quantity and preventing PSA bin congestion.
Scenario 222. Assembly line components are physically consumed, but the EWM-PSA stock remains unupdated, leading to logical inventory bloat. How do you resolve this consumption update failure?
Answer: this stock update failure indicates a communication breakdown post-backflush. I would resolve the discrepancy using the following steps. 1. Analyze backflush confirmations. Check if the ERP production order confirmation transaction CO15 or CO11N was posted successfully in the ERP ledger. 2. Check outbound queues SMQ1. Inspect the outbound queues in ERP for stuck messages trying to communicate the backflush to the EWM warehouse. 3. Validate production consumption settings. Ensure the goods issue posting is configured to happen automatically upon confirmation in the EWM-PP parameters. 4. Verify PSA stock type mapping. Confirm that the stock type used at the PSA is mapped to the correct availability group to allow automatic goods issue. Pro tip: if backflushing fails frequently due to temporary locks, configure the ERP system to process backflushes asynchronously in the background. This decouples the physical assembly line confirmation from the EWM stock update, preventing line side stops.
Scenario 223. A production run is cancelled, and raw materials already backflushed in EWM must be returned to the warehouse. How do you execute this reversal and return of production consumption?
Answer: reversing consumption requires a systematic reversal in the ERP ledger followed by a physical return task. I would execute the process as follows. 1. Cancel production confirmation. Reverse the confirmation in ERP transaction CO13 to trigger a reverse goods issue in the system. 2. Identify stock at PSA. Verify the returned stock is visible in the physical PSA bin in the EWM warehouse monitor. 3. Generate clear PSA task. Use the clear PSA node in /SCWM/mon to trigger a return to stock movement for the specific PMR. 4. Confirm put-away task. Confirm the generated ad hoc warehouse task to physically place the materials back into the main reserve racking. Pro tip: Use clear PSA functionality in the warehouse monitor. This utility allows you to find any unused raw materials left over at the PSA after a production run is complete, and automatically generates return tasks to move them back to the main reserve racking, keeping the production floor clean and inventory accurate.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 224. Finished goods are received from the assembly line, but EWM fails to automatically create the handling units, requiring manual packing at the dock. How do you troubleshoot this automatic HU creation failure?
Answer: auto packing failures during production receipt indicate a packaging specification gap. I would troubleshoot the failure using the following steps. 1. Check packing specifications. Verify that a valid packaging specification, for example, in transaction/SCWM/PS is active for the finished product. 2. Verify inbound delivery settings. Ensure the goods receipt delivery type is configured to auto-pack upon creation. 3. Validate condition records. In transaction/SCWM/packins or the corresponding packaging condition records, check if the records for automatic packing are maintained for the material. 4. Check RF receive transaction. Ensure the operator is using the correct RF transaction such as receipt from production that supports auto-packing. Pro tip: if the finished product is batch managed, ensure the batch is created before the receipt from production. If the batch does not exist, the auto-packing engine cannot resolve the batch classification, causing the HU creation to fail.
Scenario 225. A Kanban container is set to empty on the shop floor, but EWM fails to create the replenishment task to restock the bin. How do you troubleshoot this Kanban triggering failure?
Answer: this indicates a failure in the communication between Kanban and the EWM replenishment engine. I would resolve the issue using the following steps. 1. Verify Kanban control cycle. Confirm that the control cycle transaction PKMC is set to EWM replenishment with the correct warehouse and plant mapping. 2. Check PPF action for Kanban. In transaction SBPFP, check the Kanban replenishment PPF action, for example, the /SCWM/Kanban_replenish action if standard in your target system. 3. Validate bin assignment. Ensure the destination bin in the Kanban board matches the EWM-PSA bin assignment. 4. Check stock and source storage type. Verify that available, unrestricted stock exists in the source storage type to fulfill the replenishment. Pro tip: if Kanban signals are dropping intermittently, check transaction SMQ2 for stuck queues with the prefix KB. S/4HANA communicates Kanban empty and full signals via specialized QRFCs, and any locking error on the material master will block the replenishment task.
Scenario 226. Production is complete, but several pallets of components are left unused at the Production Supply Area PSA. How do you systematically clear the PSA in EWM?
Answer: clearing a PSA requires identifying completed orders and generating return to stock tasks. I would execute the process as follows. 1. Verify order status. Ensure the production order status is set to technically complete TCO in the S/4HANA ERP system. 2. Run PSA clearing utility. Access transaction/scwm/clear_PSA or use the Clear PSA node in the EWM warehouse monitor. 3. Select unused components. Identify the components in the PSA that are no longer assigned to any active PMR. 4. Execute return to stock tasks. Confirm the generated ad hoc warehouse tasks to physically return the stock to the main reserve racking. Pro tip: always perform PSA clearing before setting the production order to closed CLSD in ERP. Once the order is closed, the EWM-PMR is archived, and EWM will refuse to process any automatic returns or consumption reversals for that specific order.
Scenario 227. A production run yields co-products or byproducts, but EWM fails to process their receipt along with the finished goods. How do you configure and handle this multi-product receipt?
Answer: handling co-products requires BOM-level integration and dedicated stock type mappings. I would configure and process the receipt as follows. 1. Verify BOM definition. Ensure the co-product or byproduct is defined with a negative quantity in the ERP bill of materials BOM. 2. Check inbound delivery item types. Confirm that the inbound delivery generated from production contains separate line items for the co-products. 3. Verify stock type mapping. Ensure EWM has specific stock types configured to receive these secondary products. 4. Confirm goods receipt on RF. Use the RF transaction for receipt from production to scan and post goods receipt for both the main product and co-products. Pro tip: for co-products, ensure batch management is active. Since co-products often have different shelf lives and quality attributes than the main finished goods, EWM must generate separate batch numbers during receipt to maintain strict traceability and compliance.
Category 22 Conclusion.
Mastering EWM-PP production integration is essential for running a highly responsive, just-in-time manufacturing facility. By implementing PMR-driven staging, precise PSA clearing processes, and automated backflushes, you eliminate material delays at the assembly line and guarantee that production consumption is recorded without logical inventory latency.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 22 to Category 23.
While feeding materials directly to production is critical, manufacturing and purchasing are heavily dependent on another core business requirement: quality control. You cannot assemble or ship products that do not meet strict regulatory and safety standards. We now transition from raw material staging to compliance and inspection. Quality management integration. This is where EWM partners with QM to govern inspection lots, manage usage decisions, handle destructive testing samples, and quarantine blocked stock. Let's explore Category 23.
Category 23. Quality Management Scenarios EWM-QM.
EWM-QM integration ensures that goods received or produced undergo strict, system-enforced quality checks before they can be released to unrestricted inventory. This category covers the diagnostic paths for failed inspection lot creation, processing partial decisions, routing rejected stock to scrap zones, and handling skip lot processes. Mastering these integration points is essential for maintaining total quality compliance and product safety.
Category 23. Quality Management Scenarios.
Here are the 7 critical scenarios covered in this category. Scenario 228. Inspection lot not generated in ERP after GR in EWM. Scenario 229. Usage decision UD made in ERP but stock type not changed in EWM. Scenario 230. Partial acceptance and partial rejection of the same inspection lot. Scenario 231. Destructive testing sample removal process handling. Scenario 232. Quality routing to a scrap zone post-rejection failing. Scenario 233. Recurring inspection triggering unexpectedly for batch stock. Scenario 234. Skip lot processing overriding EWM quality routing. Total 7 scenarios. Let's dive into Scenario 228.
Scenario 228. A high-value purchase order is received, and goods receipt is posted in EWM, but the corresponding inspection lot fails to generate in ERP-QM, allowing the stock to remain uninspected. How do you troubleshoot and resolve this lot generation failure?
Answer: this is typically an integration failure at the document replication layer. I would troubleshoot and resolve the issue using the following steps. 1. Verify inspection object type IoT activation. Confirm that IoT4Q inspection product and batch inbound DEL is activated for your warehouse in the EWM configuration. 2. Check inbound QRFC queues. Analyze transactions SMQ2 EWM and SMQ1 ERP for failed queues such as those starting with WMQF that may have blocked the creation. 3. Verify quality inspection setup. Verify the corresponding EWM-QM setup, for example, the /SCWM/QR setup transaction, or the standard inspection rules configuration to ensure a valid rule exists for the product. 4. Validate ERP Material Master QM view. Check the ERP Material Master to confirm that the relevant inspection type such as 01 or 1701 is active and flagged for automatic assignment. Pro tip: in S/4HANA Embedded EWM, you can run inspections without inspection rules. If you choose this path, ensure that the active IoT setting is explicitly set to no inspection rule. Otherwise, the system will still search for /SCWM/QR setup records and fail silently.
Scenario 229. A quality inspector records a release usage decision in ERP transaction QA11, but the stock type in EWM remains stuck as quality inspection Q3 or Q4, blocking outbound shipping. How do you resolve this status desynchronization?
Answer: this status mismatch indicates a queue block or an incomplete follow-up action. I would resolve the desynchronization as follows. 1. Check outbound queues in ERP SMQ1. Inspect ERP transaction SMQ1 for stuck queues trying to communicate the usage decision UD back to EWM. 2. Verify code group mapping. Ensure that the ERP usage decision catalog codes, for example, selected set UD codes are correctly mapped to EWM stock types, for example, F2 or F4 in the configuration. 3. Validate stock synchronization. Check the EWM warehouse monitor to confirm if there are any open put-away tasks for the affected handling unit. EWM will refuse to change the stock type if an active task is locking the HU. 4. Manually process the posting change. If the automated queue cannot be cleared, use the warehouse monitor or the standard posting change tools such as transaction/scwm/im_PC to manually release the stock. Pro tip: check if the ERP usage decision is set to trigger follow-up actions automatically. In S/4HANA EWM integration, the trigger follow-up flag must be enabled in the EWM warehouse-specific IoT settings to allow EWM to automatically generate the background posting change task.
Scenario 230. An inspection lot of 100 units has 80 units accepted as unrestricted and 20 units rejected due to defects. How do you handle this partial usage decision in EWM without breaking the document flow?
Answer: handling a partial usage decision UD in EWM requires splitting the stock logically and physically at the database level. I would execute the partial decision in S/4HANA using transaction QA11 or /scwm/qinsp_S4. The inspector records 80 units as accepted and 20 units as rejected. EWM's integration engine automatically processes this split by generating two distinct follow-up warehouse tasks. The first task moves the 80 accepted units from the quality staging zone to the unrestricted use racking, while the second task automatically routes the 20 rejected units to the scrap or quarantine zone, updating the stock types to unrestricted and blocked stock types, for example, F2 and B2 depending on implementation respectively, maintaining absolute ledger integrity. Pro tip: when processing a partial usage decision for stock packed and handling units, you must select both line items, the accepted and rejected quantities, together in the EWM inspection screen and complete the trigger follow-up action before saving. If you attempt to save the decision for only one part of the HU, the system will throw an incomplete put-away for posting change error and lock the queue.
Scenario 231. A pharmaceutical client requires 2 units from every inbound batch to be removed and sent to a lab for destructive testing, but the system is blocking the goods issue of the sample. Throwing a stock does not exist error. How do you configure and resolve this sampling issue?
Answer: this is caused by a failure in the sampling movement or HU splitting logic. I would resolve the issue using the following steps. 1. Check sample drawing procedure. Verify that the sampling procedure in ERP-QM is correctly mapped to EWM's quality inspection engine QIE settings. 2. Verify movement type mapping. Confirm that the sampling movement type, such as 331 for sample from quality stock, is correctly mapped to an active EWM warehouse process type. 3. Validate HU splitting logic. If the sample is picked from an HU managed bin, ensure that partial HU picking is permitted so EWM can split the 2 units out of the parent HU. 4. Clear stuck queues SMQ2. Check the inbound queues for any blocked messages of type WMQF that may have failed with a stock for required data does not exist error. Pro tip: in EWM-QM, destructive samples are physically destroyed in the lab. EWM must post a goods issue for the sample quantity to write it out of the warehouse. Ensure that the GL accounts and cost centers are correctly configured in transaction OBYC for movement type 331 to prevent accounting interface failures from blocking the queue.
The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 232. A batch fails inspection, and the usage decision is recorded as reject or scrap, but the system fails to create the warehouse task to route the stock to the scrap zone, leaving it stuck in the quality lane. How do you troubleshoot this routing failure?
Answer: this is caused by a configuration gap in the follow-up action or physical path. I would resolve the failure using the following steps. 1. Verify follow-up action mapping. In the EWM-QM configuration, check that the scrap follow-up action is correctly mapped to a specific EWM warehouse process type. 2. Check Layout-Oriented Storage Control (LOSC). Verify if LOSC is blocking the path between the Quality Work Center and the physical scrap storage type. 3. Check Storage Type Search Sequence (STSS). Verify that the scrap storage type has a valid put-away strategy and available destination bins to receive the rejected stock. 4. Analyze queue errors SMQ1 and SMQ2. Check the RFC transaction queues for any failed messages trying to post the transfer task back to the ERP system. Pro tip: ensure the follow-on scrap task is not failing due to stock category mismatches. If the WPT is configured to move unrestricted stock, but the rejected batch is logically marked as blocked B2, the system will fail to generate the task. The WPT must be configured to process blocked stock types.
Scenario 233. A batch-managed material has been moved to unrestricted stock, but the system unexpectedly triggers a new quality inspection task, blocking the stock from being picked for open outbound deliveries. How do you troubleshoot this recurring inspection issue?
Answer: this usually indicates an outdated next inspection date or an aggressive background check. I would resolve the issue using the following steps. 1. Check ERP Material Master QM View. Confirm if inspection type 09 recurring inspection of batches is active and check the next inspection date field in the batch master. 2. Check SLED and SLED monitoring settings. In the EWM storage type configuration, verify if shelf life expiration date SLED monitoring is active. 3. Check batch next inspection date. Ensure that the batch master's next inspection date has not been set to a past date by a background job or a mass update. 4. Analyze background job schedules. Check transaction SM37 to verify that the recurring inspection background jobs are scheduled and running correctly. Pro tip: in S/4HANA EWM, a recurring inspection lot type 09 will automatically change the EWM stock type from unrestricted F2 to quality Q2 when the next inspection date is reached. If this is happening unexpectedly, it is usually because the next inspection date is calculated based on the GR date instead of the actual production date.
Scenario 234. A trusted supplier has achieved skip lot status in S/4HANA QM, meaning their deliveries should bypass quality inspection and go straight to unrestricted racking. However, EWM's Process-Oriented Storage Control (POSC) is still routing the physical pallets to the Quality Work Center. How do you resolve this routing override?
Answer: this issue represents a disconnect between ERP skip lot status and EWM's layout-oriented or process-oriented storage control rules. In a standard integration, when ERP-QM determines a skip, it creates an inspection lot with skip status and immediately sends the usage decision to EWM. However, if your EWM-POSC is configured to always route incoming pallets to a Quality Work Center QIS step first, EWM will physically move the pallet there even if the inspection is logically skipped. To resolve this, I would configure the EWM quality step in the POSC profile as a rule-based step. This ensures that when EWM receives the skip event from S/4HANA, the system dynamically marks the quality step as completed and changes the task destination to the final unrestricted racking, bypassing the physical work center. Pro tip: do not mix ERP dynamic modification with EWM dynamic modification. If you want S/4HANA to handle the skip lot logic, ensure that the skip information is transmitted to EWM via the IoT4 interface, and do not maintain separate EWM side/SCWM/QR setup rules for the same product. Otherwise, you will create database locks and stuck queues at the gate.
Category 23 Conclusion.
Mastering EWM-QM quality integration is the ultimate standard for warehouse compliance. By implementing structured IoT4 configurations, partial usage decisions, and rule-based POSC skip lot bypasses, you ensure that every vaccine, chemical, or high-value component is strictly quarantined, audited, and processed without creating operational or ledger bottlenecks.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 23 to Category 24.
While maintaining strict quality standards is critical, warehousing is not just about storing and checking goods. To remain competitive, modern distribution centers must act as dynamic fulfillment hubs, performing specialized packaging, branding, and kitting just in time before shipment. We now transition from quality compliance to value-added warehouse operations, value-added services, and kitting. This is where EWM controls the on-the-fly assembly, repacking, and reverse kitting of products. Let's explore Category 24.
Category 24. Value-added services VAS and kitting scenarios.
Value-added services VAS and kitting scenarios test your ability to configure intermediate customization steps within the warehouse flow. This category covers automatic VAS order creation during put-away POSC, kit-to-stock KTS production integration, kit-to-order KTO outbound kitting, and reverse kitting disassembly. Mastering these scenarios ensures you can deliver high-value warehouse personalization while maintaining precise inventory tracking and costing.
Category 24. Value-added services VAS and kitting scenarios.
Here are the 6 critical scenarios covered in this category. Scenario 235. VAS order not generated automatically during inbound POSC. Scenario 236. Kitting to stock KTS component picking WT not created. Scenario 237. Kitting to order KTO delivery not updating after kit assembly. Scenario 238. Reverse kitting disassembly requirement for customer returns. Scenario 239. Capturing auxiliary packaging material consumption during VAS. Scenario 240. VAS activity confirmation not updating the outbound delivery status. Total 6 scenarios. Let's dive into Scenario 235.
Scenario 235. During receiving, a multi-step put-away POSC is mapped to route pallets through a value-added services step, but EWM fails to automatically generate the VAS order, halting the intermediate repacking. How do you troubleshoot this generation failure?
Answer: this indicates a configuration gap in the VAS determination or packaging specification. I would resolve the failure using the following steps. 1. Check packaging specification selection. Verify that a valid packaging specification transaction /SCWM/PS with the correct VAS group is active and determined for the inbound delivery. 2. Verify POSC external step mapping. Confirm that the external step, for example, VAS1 is mapped to the value added services internal process step in EWM. 3. Check VAS order condition technique. In transaction /SCWM/VAS_INT, check if the condition records for automatic VAS order creation are maintained for the material. 4. Validate work center print settings. Ensure that the active packing work center is linked to the active VAS print profile to allow the system to initialize the order. Pro tip: use transaction /SCWM/VAS_KTS or /SCWM/VAS_KTO to manually generate a test order. If manual creation succeeds but POSC fails, the issue is almost always a failure in the pack spec determination logic, specifically with the warehouse process step mapping.
Scenario 236. A kit-to-stock production order is released, and the outbound delivery is created in EWM, but the picking warehouse tasks for the individual components fail to generate, stalling the kitting station. How do you resolve this picking failure?
Answer: this is caused by a component stock deficiency or a pick-HU blocking rule. I would troubleshoot the failure using the following steps. 1. Validate component stock availability. Confirm that unrestricted, unreserved stock is available for all required components in the source storage types. 2. Check WPT for KTS outbound delivery. Ensure that the correct warehouse process type WPT is assigned to the outbound delivery of the components. 3. Verify bill of materials bomb explosion. Confirm that the ERP production order successfully exploded the bomb and transmitted the component items to EWM. 4. Review WOCR limits. Check if the warehouse order creation rules are filtering out the components due to size or weight limits. Pro tip: in KTS with VAS, the outbound delivery tasks must be picked into a pick-HU. If the system does not find a valid packaging material, or if a packaging or pick-HU determination issue occurs, EWM will refuse to create the picking warehouse tasks for the components.
Scenario 237. A physical kit header and components is successfully assembled and packed at the work center, but the EWM outbound delivery fails to update its packing status, blocking the goods issue. How do you resolve this status desynchronization?
Answer: this indicates a status desynchronization between the physical packing confirmation and the delivery record. I would resolve the issue using the following steps. 1. Check kit header generation. Ensure the Generate Kit button was executed in the packing station transaction /SCWM/pack or /SCWM/VAS_exec. 2. Verify ERP delivery item hierarchy. Confirm that the ERP sales order is configured with the correct item relationship, for example, component level versus header level billing. 3. Validate HU status in monitor. Verify that the pick-HU containing the assembled kit is not locked by an unconfirmed internal movement task. 4. Reprocess SMQ2 inbound queues. Check the EWM inbound RFC queues for blocked messages of type /SCWM/out_del that may have failed with a kit explosion error. Pro tip: S/4HANA EWM supports lean kitting or kit-to-order without VAS. In this modern model, you completely bypass VAS order creation. Pickers simply collect individual components directly into a pick HU, assemble them on the fly, and post GI at the door, which automatically posts the kit header receipt in ERP.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 238. A customer returns a promotional kit. You cannot resell the assembled kit as a single unit, and you must disassemble it back into its components to return them to standard racking. How do you design this reverse kitting process?
Answer. This is handled by initiating a reverse kitting VAS process to disassemble the kit into individual components using transaction/SCWM/VAS_INT or the corresponding execution framework as an example. Since reverse kitting is purely a warehouse internal process, EWM manually triggers a kit order for disassembly. The system automatically creates a direct outbound delivery order for the kit header to consume it from stock, and a direct inbound delivery for the individual components. The operator at the work center physically disassembles the kit, confirms the unpacking of the components, and EWM generates the required put-away warehouse tasks to return the components back to their individual storage bins, maintaining 100% accurate stock records. Pro tip: ensure batch traceability is maintained during disassembly. If the components are batch managed, the operator must record the original batch numbers during the reverse kitting process to ensure that expired or different vendor parts are not mixed in the standard racking.
Scenario 239. During a VAS repackaging step, workers consume auxiliary materials such as bubble wrap, tape, or custom inserts that must be tracked for costing, but the system is failing to capture this consumption. How do you configure this tracking?
Answer. This requires mapping auxiliary materials to packaging specifications and enabling consumption checks. I would configure the tracking using the following steps. 1. Define auxiliary packaging materials. Set up the custom inserts or bubble wrap as packaging materials in the material master. 2. Map materials to pack spec. Include these auxiliary materials in the packaging material group of your packaging specification. 3. Configure VAS activity customizing. Enable the Consume Auxiliary Materials flag in the VAS activity configuration. 4. Confirm consumption on RF. Ensure the operator scans or manually confirms the quantity of auxiliary materials consumed during transaction/SCWM/VAS exec. Pro tip: use automatic backflushing for auxiliary materials. If tracking individual rolls of tape is too tedious, configure the VAS step to automatically deduct a predefined quantity of packaging material from the bin based on the packaging specification definition every time a VAS order is completed.
Scenario 240. The VAS operator completes the custom labeling and confirms the order, but the outbound delivery status remains VAS processing, preventing goods issue. How do you resolve this status block?
Answer: this is caused by an inactive PPF status update or an overlapping quality inspection. I would resolve the status block using the following steps. 1. Check VAS activity confirmation. Verify in /scwm/VAS exec that the status of the VAS order is marked as completed value 4. 2. Verify PPF action for VAS status. In the outbound delivery, check if the PPF action that updates the delivery status upon VAS completion is active and triggered. 3. Check for block queues SMQ2. Inspect the EWM inbound queue for any locked tasks trying to update the outbound delivery status. 4. Validate status profile configuration. Ensure the active status profile assigned to your delivery item type has the value added services status correctly mapped to the VAS order lifecycle. Pro tip: if the delivery is stuck in VAS status even after confirmation, check if the quality inspection QIE step is overlapping with the VAS step. If both are active in the same POSC, EWM will hold the delivery status until both the VAS confirmation and the quality usage decision are completed in the system.
Category 24 Conclusion.
Mastering value-added services and kitting is what transforms your warehouse from a static storage space into a dynamic, customer-centric fulfillment center. By configuring automated pack specs, orchestrating kit-to-stock and kit-to-order operations, and establishing reliable tracking of auxiliary materials, you ensure the warehouse can perform highly specialized retail and promotional customization steps with absolute logical and physical accuracy.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 24 to Category 25.
While customizing and kitting inventory delivers incredible value to your customers, the ultimate goal of high-velocity logistics is to minimize stock handling time entirely. Why put away, pick, and pack a product if you can move it directly from the receiving dock to the shipping truck? We now transition from on-the-fly warehouse customization to the absolute pinnacle of lean supply chains. Cross-docking. This is where we bypass storage racks entirely to fulfill urgent demands in real time. Let's explore Category 25.
Category 25. Cross-docking scenarios.
Cross-docking is the ultimate lean warehouse strategy. designed to bypass put away and storage entirely by transferring incoming goods directly to outbound vehicles. This category covers both planned and opportunistic cross-docking, transportation cross-docking TCD for multi-node logistics, and advanced push deployment. Mastering these scenarios ensures you can configure high-velocity material flows while maintaining strict compliance, batch controls, and quality standards.
Category 25, Cross-docking scenarios.
Here are the 4 critical scenarios covered in this category. Scenario 241. Opportunistic cross-docking not triggering despite backordered sales order. Scenario 242. Planned cross-docking bypassing quality inspection incorrectly. Scenario 243. Transportation cross-docking TCD routing issue between warehouses. Scenario 244. Push deployment cross-docking from production direct to outbound. Total 4 scenarios. Let's dive into Scenario 241.
Scenario 241. An inbound delivery is posted at the receiving dock, and a matching backordered sales order exists in ERP, but EWM fails to trigger opportunistic cross-docking, creating standard put-away tasks instead. How do you troubleshoot this triggering failure?
Answer: this is caused by a failure to meet EWM's cross-docking prerequisites. I would troubleshoot and resolve the issue using the following steps. 1. Verify cross-docking activation. Verify opportunistic cross-docking activation and determination settings, for example, in transaction/SCWM/CDOP. 2. Check product master settings. Ensure that the product has the cross-docking product group type and product group assigned in the warehouse product master. 3. Validate stock type mapping. Verify that the incoming stock type, for example, F2 matches the stock type of the outbound sales order, for example, F1, to allow the system-guided mapping. 4. Check stock removal strategy. Confirm that the stock removal strategy includes the inbound or staging storage types as a valid search source for task creation. Pro tip: in opportunistic cross-docking, the system must not find any quality inspection QI or FIFO first in, first out restrictions. If the product requires quality clearance, or if EWM's FIFO strategy blocks picking a newly received batch over an older existing batch, the system will automatically bypass cross-docking to enforce stock integrity.
Scenario 242. A planned cross-docking run is executed, but the system is routing incoming pallets directly to outbound shipping doors while completely bypassing the mandatory quality inspection step, violating compliance. How do you correct this security failure?
Answer: this indicates a gap in the connection between EWM-QM and the cross-docking routing. I would correct the configuration using the following steps. 1. Check quality inspection engine QIE settings. In transaction/SCWM/QR setup, verify if the product or vendor is flagged for mandatory inbound quality inspection. 2. Review POSC storage steps. Ensure that the process-oriented storage control POSC profile includes the quality inspection step QIS before the cross-docking step. 3. Validate cross-docking relevance. Ensure that the cross-docking relevance is configured to evaluate quality status before task generation. 4. Review stock type transitions. Verify that the incoming stock remains in quality status Q4 and is not automatically converted to unrestricted during the cross-docking task creation. Pro tip: in planned cross-docking, never allow unconditional cross-docking for products with active QM indicators. By configuring conditional cross-docking, you force the system to check table/SCWM/QINS_S4 to verify if the inspection lot has achieved a released usage decision before generating the cross-dock task.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 243. A multi-node stock transfer is planned where goods should route from a main hub to a regional warehouse via an intermediate cross-docking hub, but EWM fails to generate the TCD-specific outbound delivery at the intermediate node. How do you resolve this routing issue?
Answer: this is caused by a mismatch in the route determination or delivery profiles. I would resolve the routing issue using the following steps. 1. Verify STO configuration. In S/4HANA ERP, ensure that the stock transfer order STO contains the correct cross-docking route mapped to the intermediate hub. 2. Verify TCD delivery configuration. Verify TCD delivery determination and route configuration, for example, checking the standard BC set /SCWM/DLV_TCD or the delivery split profiles. 3. Analyze queue errors SMQ2. Check the inbound RFC queues at the intermediate hub for any blocked messages containing delivery splits or routing errors. 4. Check HU special processing. If the intermediate hub uses specialized handling, ensure the custom RF packing tools can process the incoming handling units HUs without breaking the TCD relationship. Pro tip: in TCD, EWM does not put the goods away at the intermediate hub. Instead, the system automatically creates a cross-docking warehouse task to update the inbound delivery and the new outbound delivery simultaneously upon goods receipt, placing the stock directly in transit to the final destination.
Scenario 244. A manufacturing plant needs a dynamic push deployment process where finished goods received from production are routed directly to waiting outbound shipments without ever being put away in the warehouse. How do you design and optimize this opportunistic cross-docking flow?
Answer: this can be integrated with advanced planning solutions such as SAP APO or Integrated Business Planning (IBP) to handle push deployment PD. In this process, when EWM posts goods receipt from production, the system does not automatically generate the put-away tasks. Instead, it triggers a put-away delay via the PPF. EWM communicates the received stock to the planning system, which immediately checks for unconfirmed sales orders or urgent stock transfer requirements across other warehouses. If a demand is found, S/4HANA generates an outbound delivery order, and EWM automatically creates a picking warehouse task directly from the goods receipt staging lane to the outbound dock door, achieving a highly optimized, zero-storage fulfillment flow. Pro tip: pay close attention to the put-away delay timer in the warehouse process type configuration. If the delay is set too short, for example, under 5 minutes, EWM will assume the planning system has no demand and will automatically generate standard put-away tasks to the racking, completely bypassing the opportunity for a push deployment.
Category 25 Conclusion.
Mastering cross-docking represents the absolute pinnacle of lean supply chain execution. By configuring robust planned and opportunistic cross-docking rules, resolving TCD multi-node routing issues, and designing automated push deployments, you ensure the warehouse can bypass storage racks entirely to fulfill urgent customer demands in real time, drastically reducing handling costs and maximizing warehouse velocity.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 25 to Category 26.
While bypassing storage to speed up outbound shipments represents the peak of forward logistics, modern businesses must also master reverse logistics. Returned goods can quickly pile up, creating severe dock congestion and logical inventory confusion if not managed systematically. We now transition from shipping bypasses to the world of automated reverse logistics. Returns management and advanced returns management. This is where we use S/4HANA ARM to automate inspect-to-route workflows, return-to-vendor operations, and high-volume e-commerce sorting. Let's explore Category 26.
Category 26. Returns Management Scenarios ARM.
S/4HANA Advanced Returns Management ARM is the most powerful framework for automating and tracking reverse logistics in EWM. This category covers the complexities of processing customer returns, automating warehouse inspection documents, executing direct supplier returns, and handling high-volume unsorted e-commerce returns. Mastering these scenarios ensures you can streamline return processing while maintaining strict quality, financial, and inventory compliance.
Category 26. Returns Management Scenarios ARM.
Here are the 4 critical scenarios covered in this category. Scenario 245. Customer return lacking original billing document reference. Scenario 246. Routing returned goods directly to a vendor return to vendor. Scenario 247. Automatic creation of inspection document upon customer return GR. Scenario 248. E-commerce high-volume unsorted returns handling. Total 4 scenarios. Let's dive into Scenario 245.
Scenario 245. A customer returns an expensive retail item without providing any receipt or invoice number, and the system is blocking the creation of the return order because the original billing document reference is missing. How do you bypass this validation while maintaining financial traceability?
Answer: this is resolved by utilizing the advanced document flexibility of the ARM framework. I would execute the process as follows. 1. Leverage Advanced Returns Management ARM. Create the returns order using standard S/4HANA ARM sales document types. For example, the standard document types RE2 or CBAR, which support reference-free returns. 2. Configure reference-free return reason. Map a specific unreferenced return reason in the S/4HANA configuration to allow the order to bypass the mandatory reference check. 3. Automate valuation and credit block. Configure the system to automatically place a billing block on the return order until the warehouse physically inspects and confirms the item's legitimacy. 4. Check inbound delivery replication. Verify that the inbound delivery is generated successfully and replicated to EWM with a specific ARM indicator. Pro tip: in reference-free ARM returns, always configure the system to post the goods receipt into a non-valuated return stock type first. This protects your financial ledger from being impacted by unverified inventory value until the quality inspector physically completes the warehouse inspection.
Scenario 246. A customer returns a defective laptop under warranty. The warehouse inspector determines that the unit must be returned directly to the original supplier returned to vendor, but the system is failing to automate the shipping documentation. How do you configure and troubleshoot this direct supplier return?
Answer: this requires configuring the automated follow-up actions within the ARM warehouse inspection. I would resolve the issue using the following steps. 1. Assign follow-up code. In the S/4HANA warehouse inspection screen transaction MSR_INSP-WH, assign the standard follow-up code for return to vendor, for example, code 0005, or the equivalent supplier return code to the inspection lot. 2. Verify purchasing data for plant. Ensure that the shipping data for plant's configuration is fully maintained in SPRO to allow the automated creation of the outbound delivery. 3. Check outbound delivery generation. Verify that S/4HANA automatically generates the outbound delivery order, such as standard delivery types RL or LR2 for the vendor return. 4. Analyze queue errors SMQ1 and SMQ2. Check the RFC transaction queues for any failed messages trying to replicate the outbound delivery to EWM. Pro tip: for automated return to vendor execution, ensure that the vendor business partner is flagged as a supplier and mapped to a customer role in the ERP configuration. If this cross-role mapping is missing, the system will fail to determine the shipping point and block the outbound delivery creation.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 247. A customer return delivery is received at the dock and goods receipt is posted in EWM, but the system fails to automatically generate the quality inspection document, blocking the inspection team from recording results. How do you troubleshoot this triggering failure?
Answer: this is caused by a missing link in the QIE or delivery type mapping. I would resolve the issue using the following steps. 1. Verify quality inspection engine QIE activation. Confirm that the EWM-QM integration is active for the warehouse and that the inbound delivery item type is mapped to an active inspection object type IoT. 2. Verify BC set activation. Ensure that the standard EWM configuration and BC sets for RM delivery types, for example, the standard ARM delivery type transfer BC sets, are fully active and mapped in EWM. 3. Check inbound queues for message blocks. Analyze transaction SMQ2 for any failed queues of type WM-QF that may have blocked the replication of the inspection document. 4. Check inspection rules. Confirm if a valid inspection rule exists for the product, returning customer, or warehouse number to trigger the automatic document generation. Pro tip: in S/4HANA ARM integration, the EWM goods receipt automatically triggers the creation of the inspection lot in ERP-QM. Ensure that the inspection lot type 1701 is active in the ERP material master. If this specific integration type is missing, the ERP system will refuse the GR update and block the queue.
Scenario 248. An e-commerce warehouse receives thousands of returned single-item parcels daily from different customers. Sorting these individual returns manually is creating a severe bottleneck at the receiving dock. How do you design an efficient, high-volume unsorted returns process in EWM?
Answer: to handle high-volume unsorted returns, I would implement a pre-sorting and consolidation process using S/4HANA Advanced Returns Management. First, instead of creating individual return orders for each parcel at the gate, we receive all unclassified parcels into a single, generic collective return delivery in EWM. The physical parcels are routed to a specialized returns work center equipped with Fiori apps like Manage Customer Returns or MSR_INSPWH. The operator scans the parcel's return barcode, which automatically identifies the customer and order. The operator then performs a one-click physical inspection, for example, a fit for resale or be defective, and EWM immediately generates the follow-on tasks to route the item either to the unrestricted pick face or to the scrap zone, automating the entire reverse logistics stream in seconds. Pro tip: leverage unsorted return storage processes. By configuring EWM to put away these unsorted parcels into a dedicated buffer zone before the formal inspection, you can unload the trucks instantly and keep your receiving dock completely clear, deferring the labor-intensive inspection step to a quieter shift.
Category 26 Conclusion.
Mastering Advanced Returns Management ARM is what separates a standard warehouse setup from a highly efficient reverse logistics operation. By implementing unreferenced returns with non-valuated stock, automating supplier returns via MSR_INSPWH, and building high-volume unsorted returns work centers, you ensure that returned inventory is quickly inspected, logically routed, and physically cleared from your docks.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 26 to Category 27.
While automating physical product flows and return routes keeps the warehouse efficient, the most expensive and variable resource in any warehouse is the human workforce. You cannot manage what you do not measure. We now transition from inventory movements to the optimization of your most valuable asset, your people. Welcome to labor management. This is where EWM calculates planned times, tracks indirect activities, and evaluates employee performance. Let's explore Category 27.
Category 27. Labor Management Scenarios LM.
Labor Management LM provides complete visibility into workforce productivity and efficiency. This category covers engineered labor standards ELS, indirect labor task recording, processor performance evaluation, and travel distance network calculations. Mastering these scenarios ensures you can accurately measure labor costs, plan shifts, and eliminate execution bottlenecks.
Category 27. Labor Management Scenarios LM.
Here are the 4 critical scenarios covered in this category. Scenario 249. Engineered labor standards ELS planned time not calculating correctly. Scenario 250. Indirect labor tasks, for example, sweeping, meetings not recorded for user. Scenario 251. Processor performance document not generated after WT confirmation. Scenario 252. Travel distance calculation using network returning zero distance. Total 4 scenarios. Let's dive into Scenario 249.
Scenario 249. After releasing a picking wave, you notice that the planned execution time for the warehouse orders is either returning 0 or calculating extremely unrealistic durations, corrupting your shift planning. How do you troubleshoot this ELS calculation failure?
Answer: this usually indicates a gap in labor management master data, ELS rule configuration, or travel distance calculation inputs. I would resolve the issue using the following checks. 1. Verify labor management activation. Confirm that labor management is active for your warehouse number in the global settings. 2. Check activity and external step mapping. Verify that the warehouse process type and its internal activities are mapped to valid external process steps in the labor management config. 3. Check BRF plus or ELS rule configuration. Ensure that the business rule framework plus BRF plus or standard ELS formula is correctly mapped to evaluate based on the product's weight, volume, or bin distance. 4. Validate product master LM attributes. Verify that the gross weight, volume, and packaging dimensions are fully maintained in the product master. Empty master data will result in zero duration calculations. Pro tip: use transaction SLG1 with object/SCWM/LM subobject ELS to trace the calculation engine. The log will show you exactly which BRF plus rule was triggered and which variable such as missing travel speed or empty product weight caused the calculation to fail.
Scenario 250. Warehouse workers are physically performing essential non-system tasks like sweeping, safety meetings, and equipment checks, but the system is failing to log these hours, making their productivity metrics look artificially low. How do you resolve this indirect labor tracking issue?
Answer: recording non-system labor requires setting up indirect activities and processor profiles. I would troubleshoot the issue using the following steps. 1. Enable standard document customizing. Verify that the standard EWM document settings for indirect labor tasks are fully active in the labor management customizing. 2. Define labor activities for INDLE. Ensure that the internal process step INDLE indirect labor is active and that your external activities, for example, sweeping, meetings are mapped to valid labor activities. 3. Check user business partner setup. Confirm that the warehouse worker is created as a processor business partner and has the correct shift and external steps assigned. 4. Verify indirect labor recording access. Ensure that the worker can access the indirect labor recording application, for example, transaction/SCWM/ILT or the corresponding Fiori app, or use the RF transaction. Pro tip: integrate indirect labor task recording directly into the RF menu. This allows workers to easily clock into a meeting or a cleaning task straight from their handheld devices, reducing administrative delay and ensuring 100% of their warehouse hours are captured.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Scenario 251. A picker completes and confirms their warehouse tasks, but the system fails to generate an evaluated performance document (EPD) for their user profile, making it impossible for supervisors to measure their output. How do you troubleshoot this performance tracking failure?
Answer: this indicates a configuration gap in the performance evaluation triggering rules. I would resolve the issue using the following steps. 1. Check active for labor management flag. Verify that the active for LM flag is enabled in the business partner settings for the processor, the worker. 2. Verify EPD number range configuration. Confirm that the standard number range configuration for evaluated performance documents (EPDs) is created and assigned to the warehouse. 3. Check warehouse activity LM activation. Ensure that labor management is active for the specific activity such as pick or PTWY in the WPT or activity area settings. 4. Analyze queue errors SMQ2. Check the inbound RFC queues for any blocked messages that may have failed while trying to write the executed workload to the performance ledger. Pro tip: in EWM, performance documents are generated when a warehouse order is fully confirmed. If a picker has confirmed all but one task in a warehouse order, the system will hold the EPD in open status and will not generate the final performance metrics until that last task is closed.
Scenario 252. The system is calculating zero travel distance for forklift movements between aisles, causing the planned travel times to be completely inaccurate in your labor reports. How do you resolve this travel network calculation failure?
Answer: this is caused by an incomplete or broken travel network configuration. I would resolve the issue using the following steps. 1. Verify travel network activation. Confirm that the travel distance calculation TDC is active for the warehouse and that the coordinates check is enabled. 2. Check storage bin coordinates. Verify that the X, Y, and Z physical coordinates are accurately maintained for every storage bin in the ELA-GP table. 3. Verify network path and edges mapping. Check the travel network configuration, for example, transaction/SCWM/TDC, to ensure that nodes and edges aisle paths are correctly defined between activity areas. 4. Validate speed and resource attributes. Ensure the resource type has a valid travel speed defined. If the speed is 0, EWM will struggle to calculate distance over time. Pro tip: when configuring travel distance calculation TDC, always run the travel network generation utility, for example, transaction/SCWM/TDC_gen, or the equivalent system program, after adding new bins or aisles. This automatically rebuilds the network connections, connecting orphan bins to the main travel network and eliminating zero-distance calculation errors.
Category 27, Conclusion.
Mastering labor management is what elevates an EWM design from a purely functional layout to a highly optimized, high-performance operation. By configuring precise engineered labor standards (ELS), tracking indirect labor tasks, and establishing accurate travel distance networks, you ensure that the warehouse's most variable and expensive resource, its workforce, is visible, measurable, and continuously optimized.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Transition from Category 27 to Category 28.
While managing labor and physical execution forms the operational core of EWM, the technology driving these platforms is undergoing a rapid evolution. The era of classic, siloed decentralized systems is giving way to real-time integration, unified data layers, and intuitive web interfaces. We now transition to the absolute cutting edge of the SAP ecosystem. Modern S/4HANA embedded in cloud scenarios. This is where we handle advanced shipping and receiving, synchronous database postings, Fiori extensibility, and the cloud-native architectures of the future. Let's explore Category 28.
Category 28. Modern S/4HANA Embedded and Cloud Scenarios ASR and Fiori.
Modern S/4HANA embedded and cloud scenarios represent the present and future direction of SAP's warehouse management roadmap. This category covers the newest features in S/4HANA, including advanced shipping and receiving ASR, which eliminates EWM transportation units, synchronous goods, receipts bypassing QRFC queues, extending Fiori elements, and managing the strict functional restrictions of S/4HANA Cloud Public Edition versus Private Edition. Mastering these scenarios ensures you can deliver robust, future-proof warehouse designs.
Category 28. Modern S/4HANA Embedded and Cloud Scenarios.
Here are the 5 critical scenarios covered in this category. Scenario 253. Advanced shipping and receiving ASR integration failing without TU. Scenario 254. Synchronous goods receipt for external procurement bypassing queue. Scenario 255. Standard Fiori app not displaying custom fields added to EWM delivery. Scenario 256. Transitioning from decentralized EWM to embedded EWM migration. Scenario 257. Handling restriction differences in S/4HANA Cloud Public Edition versus private. Total 5 scenarios. Let's dive into Scenario 253.
Scenario 253. S/4HANA EWM is configured to use the new advanced shipping and receiving ASR process, where TM freight orders directly trigger execution. But the gate clerk is receiving errors because the system is still searching for an active EWM transportation unit TU, stalling the gate. How do you resolve this ASR integration failure?
Answer: this failure indicates a configuration conflict between the legacy TU-based model and the new ASR process. I would resolve the integration failure using the following steps. 1. Check ASR activation in warehouse. Ensure that advanced shipping and receiving is explicitly active for the specific EWM warehouse number and shipping points in the configuration. 2. Verify delivery item category settings. Check that the delivery item types are flagged as ASR relevant and not mapped to old TU-related PPF actions. 3. Analyze interface message logs. Inspect the standard XML message monitors such as transaction SRT_MONI for failed inbound messages carrying freight order execution data. 4. Validate TM execution and document flow. Confirm that the freight unit, freight order, and EWM delivery are correctly linked and that the freight order is released for execution. Pro tip: in ASR-enabled scenarios, TM freight orders become the primary execution object and traditional TU-centric processes are significantly reduced. The TM freight order is the single source of truth. If EWM still looks for a TU, it means the legacy TU-based execution settings are still active in the warehouse process type configuration. You must verify that legacy TU-based execution settings are not active to let the ASR engine take over.
Scenario 254. S/4HANA has enabled synchronous goods receipt to allow immediate, queue-free postings, but the receiving clerk reports that EWM stock is not updating in real time, and the system is still generating background QRFCs in SMQ2. How do you troubleshoot and enforce synchronous GR?
Answer: this indicates a configuration gap or an active document mismatch that is disabling the synchronous posting. I would resolve the issue using the following steps. 1. Check synchronous GR configuration. Verify that the synchronous goods receipt flag is enabled for the purchase order item type and your EWM warehouse number. 2. Verify process eligibility. Confirm that the procurement process, product attributes, and warehouse process are supported for synchronous goods receipt in your S/4HANA release. 3. Check for blocked inbound queues. Verify that no older, failing asynchronous delivery queues are currently blocked in SMQ2, which would force the system to fall back to queue-based posting. 4. Review synchronous posting logs. Review synchronous posting logs and fallback indicators to determine why the system switched back to asynchronous processing. Pro tip: synchronous goods receipt provides a real-time inventory update and significantly reduces queue dependency by processing both the ERP inventory ledger and the EWM warehouse stock in a single synchronized posting process. If the product is batch managed or requires quality inspection, ensure the batch exists and the inspection type supports synchronous postings. Otherwise, the system will automatically default back to the legacy asynchronous queue-based delivery model.
Scenario 255. A developer has added a custom field to the EWM outbound delivery table/SCWM/DLV_HDR, but the field is missing from the standard Fiori app Manage Outbound Deliveries, preventing clerks from updating it. How do you resolve this Fiori extensibility issue?
Answer: this requires extending the OData services and the CDS views to expose the custom database field. I would resolve the extensibility issue using the following steps. 1. Verify field extensibility in Custom Fields app. Ensure the custom field was created using the Fiori Custom Fields and Logic app and enabled for the corresponding OData and CDS views. 2. Check CDS view extension. Verify that the standard CDS view representing the EWM delivery header has been extended to expose the new custom field. 3. Regenerate OData service metadata. Clear the Fiori metadata cache and transaction/IWFND/cache_clean to force the UI5 client to reload the updated service definition. 4. Check Fiori UI annotations. Ensure that the custom field is mapped to a UI annotation such as @UI.lineItem or @UI.identification, so the Fiori Elements template knows where to display it on the screen. Pro tip: in modern S/4HANA EWM, avoid using classic ABAP screen exits or transaction variant adjustments to add fields to Fiori. Always use standard custom fields and logic key user extensibility, because it automatically handles the database table append, CDS view extension, O data service exposure, and Fiori UI mapping in a single, upgrade-safe workflow.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the Masterclass.
Scenario 256. A company is planning to migrate their system from a decentralized EWM instance connected to ECC to a fully S/4HANA embedded EWM architecture to simplify their IT landscape and reduce licensing costs. How do you design this migration path, and what are the key architectural changes?
Answer: transitioning from decentralized to embedded EWM represents a major architectural simplification. Since both ERP and EWM will now run on the same S/4HANA database instance, the entire core interface CIF master data replication layer is completely eliminated. Business partners, materials, and customers no longer need to be replicated via LE and I docs or integration models. EWM reads them directly from the S/4HANA master tables in real time. In my migration plan, I would first map the old decentralized warehouse logical numbers to the new S/4HANA embedded warehouse. To migrate the inventory, we can utilize the standard S/4HANA Migration Cockpit Transaction LTMC or the Fiori equivalent. The physical stock is posted directly as a goods receipt into EWM, and because it is embedded, EWM synchronously updates the S/4HANA MMIM inventory, maintaining absolute real-time consistency. Beyond technical migration, I would perform a warehouse process assessment to identify functions that behave differently in embedded EWM, including integration models, PPF processing, queue handling, RF execution flows, and custom enhancements. Pro tip: watch out for custom code incompatibilities. Decentralized EWM allows you to write custom ABAP code that assumes EWM is running on a standalone SCM database. In embedded EWM, any custom code that performs direct database selects or cross-system RFCs must be completely refactored to use standard S/4HANA APIs and CDS views. Otherwise, you will face critical performance bottlenecks and runtime dumps.
Scenario 257. A client is evaluating whether to implement S/4HANA Cloud Public Edition or Private Edition for their new automated distribution center. They have several custom automated conveyor lines and need custom ABAP code to handle complex diverter logic. How do you guide the client regarding the functional and extensibility restrictions between public and private cloud EWM?
Answer: this requires a strict evaluation of cloud extensibility limits and scope items. S/4HANA Cloud Public Edition is a highly standardized SaaS offering. Under Public Edition, EWM does not support custom ABAP code modification, classic GUI transactions, or direct MFS integration to PLCs via TCP/IP sockets. Extensibility in the public cloud is strictly limited to key user extensibility such as Fiori custom fields and developer extensibility via standard RAP APIs on the SAP Business Technology Platform BTP. If the client has complex, real-time automation requiring direct MFS telegram processing and custom ABAP logic, S/4HANA Private Cloud Edition or on-premise is the only viable option. Private Cloud provides full access to the classic ABAP and EWM codebase, custom BADIs, and the traditional EWM MFS framework, allowing you to build and debug complex automation drivers without restriction. Pro tip: for public cloud EWM implementations, if automation is required, the standard integration path is to connect EWM with an external warehouse control system WCS or material flow controller MFC using standard API and OData or IDOC services on BTP, rather than trying to run MFS directly inside the public cloud tenant.
Category 28 Conclusion.
Mastering next-generation S/4HANA and cloud EWM architectures is what separates a standard functional consultant from an enterprise solutions architect. By understanding the real-time business processes of advanced shipping and receiving, the performance benefits of synchronous goods receipts, and the strict extensibility boundaries of cloud public and private editions, you ensure your clients' platforms are designed for future scalability, seamless upgrades, and modern Fiori usability.
Part 2 Conclusion. Advanced integrations, automation, and support.
Part 2 has taken us deep into the engine room of enterprise logistics. By moving beyond standard warehouse operations, we covered the critical integration paths with ERP, TM, PP, and QM, analyzed the millisecond-level telemetry of material flow systems, mastered the real-world complexity of advanced returns and value-added services, and diagnosed database and performance bottlenecks. These advanced skills ensure you can support, optimize, and scale highly complex, automated live production environments.
The complete 257 scenario Masterclass series conclusion.
Across Part 1 and Part 2, we have meticulously mapped out a comprehensive library of 257 real-world scenarios covering the entire lifecycle of an SAP EWM implementation. From foundational inbound dock door scheduling to modern, cloud-native S/4HANA architectures. This collection represents the absolute sum of years of on-the-ground project experiences, production support resolutions, and architectural decision-making. You now hold the master key to any EWM technical, functional, or solution architect interview globally.
Bookmark, save, and watch.
This level of specialized, architect-grade detail and real-world quality simply does not exist anywhere else in online blogs, training manuals, or YouTube videos. This masterclass is an evergreen professional asset designed to build genuine career authority. Make sure to bookmark, save, and watch this series repeatedly to fully internalize these solution paths before your next major project round or technical interview. If you missed any of the foundational warehousing topics, the link to Part 1 is in the description below, along with the link to subscribe the complete 257 scenario PDF playbook on our Learnus platform. Do not forget to like, subscribe, and drop a comment below on which specific scenario you people liked most. See you in the next masterclass.
The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.